My name is Chris Blumberg. Welcome to the NTSB boardroom. I would like to share a safety briefing before we get started with today's meeting. If you have not already done so, please silence your electronic devices. Restrooms are in the lobby to the left as you exit the boardroom. In the event of an emergency, our on-site Federal Protective Service security officers have been designated to perform the following emergency response roles. They will call 911 and meet emergency personnel to guide them to the location of the emergency. They will retrieve and operate fire extinguishers. Our fire extinguishers in this facility are located near all exits: 2 behind the dais down the stairs, 2 at the back of the boardroom where you entered, and 1 by the security area in the lobby. Finally, in the event of a medical emergency, security officers will retrieve and operate our on-site defibrillator, perform CPR, and provide other life-saving first aid until responders arrive. The defibrillator is just outside the doors in front of me, outside the lobby, and our first aid kit is in conference room A, the closest room to the security area in the lobby. If there is a need to evacuate for any reason, please follow NTSB staff to the exit route, which is either to the rear of the auditorium or back through the lobby. Please walk, don't run. You'll be directed to the rally point once you exit the building. Please remain there and do not return until instructed to do so. The accessible emergency exit is through the lobby and left through the garage. NTSB staff will direct anyone needing assistance. Lastly, I'd like to remind everyone that each of us has a vital role to play in any emergency. If you see something concerning or suspicious, notify one of our NTSB staff or security right away. Thank you.
Thank you very much, Chris. On January 5th, 2024, at about 5:13 p.m. Pacific Standard Time, Alaska Airlines Flight 1282, a Boeing 737-9 airplane, experienced an in-flight separation of the left mid-exit door plug and rapid depressurization during climb after takeoff from the Portland International Airport. 1 flight attendant and 7 passengers received minor injuries. The captain, the first officer, 3 flight attendants, and 164 passengers were uninjured, and the airplane sustained substantial damage. I know I speak for the entire agency when I say how tremendously grateful we are that no one lost their life or was seriously injured in this accident. At the same time, I cannot overstate the seriousness of this event, which jeopardized the lives of all 177 souls on board and perhaps countless others on the ground. I was the board member on scene for this accident. I walked through the aircraft with our investigators and saw the damage up close. And I spoke with a few of the flight attendants in the aftermath of what was clearly a terrifying event. Frankly, it's nothing short of a miracle that no one died or sustained serious physical injuries. But as with any tragedy we investigate, there are injuries we can't see. Injuries that can have a profound impact on people's lives and livelihoods. There's no doubt that Alaska Airlines as a whole, from its top executives to its safety leadership and those on the front line, the flight attendants who I spoke with on my flight home, were shaken, devastated. Alaska Airlines was the first airline to implement a safety management system, so it's not surprising they have a strong safety record. I want to commend the entire Alaska Airlines team for working with us throughout this investigation, particularly Max Tidwell and his safety team. For those in the room, Elias Contanas from our Transportation Disaster Assistance Division right here is here and will be here throughout the entire board meeting to provide support to anyone who may need it. I firmly believe there's one reason Flight 1282 averted catastrophe, and one reason only: the crew. The actions of the captain, the first officer, 4 flight attendants, and air traffic controllers on duty that day were nothing short of heroic. While climbing through about 14,830 feet, the cabin pressure dropped and the cabin altitude warning activated, followed 1 second later by the master caution alert. According to the captain, he heard a loud bang, his ears popped, his head was pushed forward, and his headset was pushed nearly off. The first officer's ears popped, and simultaneously the flight deck door blew open, and her headset blew off. The captain and first officer immediately retrieved their emergency oxygen masks and put them on as they were trained to do. The first officer could see in her peripheral view through the open flight deck door that the cabin oxygen mask had dropped. She later saw the hand of a flight attendant shut the flight deck door. From that flight attendant. The flight door flung open and hit me, and hit the bathroom, and I flew. All I could think about was trying to close the door. I wasn't buckled in, but I had them around my arm, so I was at least attached to the airplane. And I remember trying to close it, and my upper back hurt so bad with all my might trying to close that flight deck door, I even used my feet. I was trying to kick it closed, and it would not close. Back on the flight deck, the captain asked the first officer to declare an emergency with air traffic control and request a lower altitude. According to the first officer, she used the audio control panel to select the overhead speaker, turned up the volume, and contacted air traffic control to declare an emergency. Both pilots said it was very loud, making it difficult for them to hear each other and the air traffic controller. Communications issues persisted throughout the remainder of the flight. In fact, the first officer said at one point she and the captain had to communicate using hand signals and by yelling to each other. The first officer pushed the altitude warning horn cutout switch to stop the continuous audible warning. She reached to the top of the glare shield panel to retrieve the quick reference checklist from its holder, but it wasn't there. She later found it behind her seat. The captain grabbed the quick reference handbook, and the first officer used it to start going through their emergency procedures. At some point, the captain said he heard the flight attendants over the cabin interphone talking about a hole in the cabin, and he tried to communicate with them multiple times to no avail. He wasn't sure whether they were okay and whether they could even hear them. Meanwhile, the flight attendants were trying to communicate with the pilots, but the noise was so loud in the cabin that they didn't know whether the pilots answered or if they were even okay. The pilots had no idea what was happening in the cabin, and the flight attendants had no idea what was happening on the flight deck. To quote the captain, it was an explosive experience. The first officer said it was chaos. Back in the cabin, the flight attendant saw 5 empty seats next to a gaping hole in row 26 and believed multiple passengers had been lost. From an interview, I look down the aisle and I see the mom of the child by the window. The mom was on the floor just screaming, like agony, and she was shaking. I was holding her. I said, "What's going on? What's happening?" And she just says, "I was holding my son, and I think my son blew out." That's when I lift up my head and I saw the hole and I just started shaking. It wasn't until the crew deplaned that they learned they didn't lose a single passenger, that all crew members were accounted for. Throughout this meeting, you'll hear more about what it was like on board Flight 1282 that day. I think what's most inspiring to me, and I would imagine this entire board, is amidst absolute chaos, and I imagine fear, the crew members were laser focused on the safety of their passengers. Using supplemental oxygen, the flight attendants ran up and down the aisle to check on passengers, never forgetting the most vulnerable on board, 3 lap children and 4 unaccompanied minors, one of whom was just 6 years old. He had turned 6 just about a week before, and it was his first time flying. I hope everyone in this room or watching online takes away a newfound appreciation and respect for the men and women who protect us in the air and on the ground. Above all, these highly trained professionals are there for our safety. Safety. That's the promise the Flight 1282 crew delivered on. Despite the harrowing circumstances, every single crew member performed their safety duties with the highest degree of professionalism and competence, remaining calm in the most turbulent of times. They are why all 177 souls on board Alaska Airlines Flight 1282 deplaned safely at the gate. And I want to take a moment on behalf of the entire agency to commend the entire crew. This doesn't just happen. Every single crew member we interviewed credited their training. We at the NTSB examine training in every accident we investigate, in every transportation mode. Why? Because it can and often does make the difference between life and death. When every second counts, as it did on Flight 1282, training to the point of muscle memory is paramount. In this case, the crew knew precisely what to do. They acted without hesitation, and it saved lives. And yet the crew shouldn't have had to be heroes, because this accident never should have happened. Since this accident occurred, there's been a lot of focus on human error, on the actions of one or two individual Boeing employees. Let me be clear. An accident like this does not happen because of an individual or even a group of individuals. Aviation is much more resilient than that. An accident like this only happens when there are multiple system failures. This is from the draft NTSB report we'll soon discuss. Within a robust system, the introduction of a single error is almost never the only cause of an accident. Rather, several barriers of defense must fail for the error to lead to an accident. Several barriers of defense must fail for the error to lead to an accident. The truth is, there was a long chain of events that led to the door plug departure. Problems were identified in numerous Boeing internal audits across production lines, employee speak-up reports, quality alerts, and regulatory compliance issues. In other words, the safety deficiencies that led to this accident should have been evident to Boeing and to the FAA. This time, it was missing bolts securing the door plug, but the same safety deficiencies that led to this accident could just as easily have led to other manufacturing quality escapes and perhaps other accidents, which leads me to the ultimate purpose of our investigation: to inform safety recommendations that, once implemented, will help Boeing close the systemic gaps that led to this accident, will help strengthen each barrier of defense against quality escapes, so that every airplane leaving a Boeing factory is safe to transport the most precious thing imaginable, human life. Our job is to make recommendations to prevent accidents like this from recurring. Following the accident, Boeing rolled out its safety and quality plan, which has the same goal. Will Boeing's plan, in fact, prevent accidents like this from reoccurring? Are there still gaps? We discussed some of those gaps at the hearing last August, including the need for continued development of Boeing's safety management system and improved safety culture, which they themselves recognize and have done a lot of work on. How do Boeing and FAA know the key performance indicators to measure the health of Boeing's production lines are the right ones for safety? Before the accident, multiple tiers of Boeing leadership routinely assessed quality control metrics, such as non-conformances, quality escapes, and regulatory compliance issues. What has changed? Are the processes they developed since the accident going to prevent, or at a minimum, detect the next manufacturing issue before the airplane leaves the factory, before there's an accident? I do want to commend and thank Kelly Ortberg for his safety leadership. He has made himself the accountable safety executive, and he has done a lot of work at Boeing since this accident. We've had several great discussions focused on safety since he came on board. He has a lot of work cut out for him, a lot of challenges to address, and that is going to take time. I visited Boeing and Spirit Aerosystems, my colleagues did as well, just a few weeks ago, to see some of the changes they've made since this accident occurred. I'm thankful for their progress, but you'll hear today that more can and should be done. When it comes to safety, the NTSB sets a high bar. We've been unequivocal when it comes to demanding excellence in transportation safety and demanding excellence from Boeing. Lives depend on it. Boeing is a cornerstone of American aviation. It is a pillar of American manufacturing, supporting more than 170,000 direct jobs and an estimated 1.6 million indirect jobs around the globe. I believe Boeing, Spirit, and the FAA will take the lessons learned from this accident to heart and again become a world leader on aviation safety. Please know that all the board members, the entire team at NTSB are here as a resource, not to help you meet the high expectations that we all have for you, but to actually exceed them. With that said, this isn't all on Boeing or Spirit. I have lots of questions about where FAA was during all of this. The FAA is the absolute last barrier of defense when it comes to ensuring aviation safety, protecting the more than 1 billion passengers and crew members who fly on U.S. and foreign airlines annually. Appropriate oversight of those they are charged with regulating is critical, and I am hopeful that with new leadership at DOT and at FAA, that will occur. I believe firmly that change brings about new opportunities for much-needed reform and a renewed commitment to safety, something we've seen from Secretary Duffy since day one. Let's now turn to today's meeting. I want to recognize our Managing Director, Dana Schultz, who will introduce the NTSB team participating in today's meeting. Good morning, Ms. Schultz.
Thank you, and good morning, Chairwoman Homendey and members of the board. My only administrative announcement this morning is for meeting participants to silence their electronic devices at this time. I'll now introduce staff for today's meeting. Unless otherwise noted, staff are from the Office of Aviation Safety. In the front row to my right, Tim LeBaron, Director, Office of Aviation Safety, Doug Brazy, Investigator in Charge, Pacholo Cruz, Manufacturing Records, Nils Johnson, Manufacturing Records, and Dr. Sabrina Woods, Human Performance. In the second row, directly behind me from left to right, Jen Adler, Director, Office of Safety Recommendations and Communications, Tom McMurray, General Counsel, Mike Badinsky, Acting Director, Office of Research and Engineering, Kathy Strong, Report Writer, Captain Star Blum, Operational Factors, and Crookshanks, Structures. And in the third row, behind me from left to right, Jonathan Hsu, Flight Data Recorder and Visuals from the Office of Research and Engineering, Kyle Garner, Cockpit Voice Recorder, Flight Data Recorder, and Timer, Office of Research and Engineering, Dr. Matthew Fox, Materials, also from the Office of Research and Engineering, Ms. Emily Gibson for Cabin Safety, Adam Hurray for Systems, and Mr. Nathan Hoyt, Safety Recommendations in the Office of Safety Recommendations and Communications. The presentations will begin with an investigation overview by the investigator in charge, Doug Brazy. Doug?
Thank you, Dana. Good morning, everyone. As the chairwoman mentioned, on January 5, 2024, Alaska Airlines Flight 1282 departed Portland International Airport, Portland, Oregon, destined for Ontario, California. At 5:13 p.m., about 6 minutes after takeoff, the left mid-exit door, or MED plug, opened and departed the airplane, which resulted in a rapid depressurization. While climbing through 14,830 feet, the captain recalled there was a loud bang, and the flight deck door was blown open due to the depressurization which had initiated in the cabin. Both flight crew immediately donned their oxygen masks. They recalled it was very noisy and very difficult to communicate, both among themselves and with cabin crew. They immediately contacted air traffic control and began executing emergency procedures. Meanwhile, in the cabin, the emergency oxygen masks deployed, the cabin crew performed their safety functions and other duties, which included closing the flight deck door, donning oxygen masks so that they could assist passengers, attempting to communicate with the flight crew, but it was so loud they could not hear a response, assessing the condition in the cabin, issuing instructions, and performing appropriate individual checks on passengers such as the unaccompanied minors. They also prepared the cabin for the emergency landing. The airplane returned to Portland and landed safely about 14 minutes after the MED plug separated. The crew taxied to the gate where aircraft rescue and firefighting personnel and equipment were waiting. A hole in the fuselage was located near rows 25 and 26 where the MED plug had been. The left MED plug was later recovered from a neighborhood backyard. The MED plug is a customer option used in place of an emergency exit for seating configurations that do not require additional exits. It weighs less than an exit door, is less complex, and requires less maintenance. It does not have any handles, and it is not opened or closed during flight operations, nor is it normally opened during the remainder of production. However, the left MED plug on this airplane was opened during the final assembly in Renton to allow access to an area that needed rework to rivets located in the fuselage. Although photographs and witness marks showed that the MED plug's 4 retaining bolts had been previously installed, when the airplane left the Renton facility, those bolts were missing. This slide shows the MED plug and some of its associated hardware. The left image shows a view of the interior side, and the right image shows the exterior side. Next, I'd like to show a video of an exemplar MED plug as it is being installed. It shows a technician as he is tightening 3 of the 4 MED plug bolts. This next series of slides shows how the MED plug operates. In order for the MED plug to open, as it did in the accident or for maintenance, with the 4 bolts removed, it must first move upward and then rotate outboard on its hinges. The purpose of the bolts that were missing are to prevent the MED plug from moving upwards. This diagram is an edge view of selected hardware mounted on the forward side of the MED plug and on the fuselage edge frame. The 2 bolts that should have been installed on this side of the plug are depicted in white. An identical pair of bolts on the aft side, not depicted, were also missing. Stop fittings, when engaged, prevent the MED plug from moving outward. Each one has a part mounted on the MED plug and 1 part mounted on the fuselage frame. There are 6 stop fittings on each side of the plug. With the bolts out of place, the MED plug is free to shift upward. If it moves up far enough, the stop fittings disengage. With the stop fittings disengaged, the MED plug is free to rotate outboard on its hinges. Let's go through that sequence one more time. On the left side, the plug is in a closed position. In the center image, it has shifted upward. And in the right image, it has rotated outboard along its hinges. You will hear more information about the MED plug in Mr. Cruz's and Mr. Cruikshank's presentations. The investigation found that these items were not a factor in the accident. All crew members were current and qualified. There were no scheduled or unscheduled maintenance activities with regard to the MED plug since Alaska Airlines took delivery of the airplane. No issues were found with the pre-flight inspection walk-around procedures. And the cabin pressurization system, including its auto-fail indications that occurred on previous flights, did not contribute to the accident and was not symptomatic of a problem with the MED plug. The investigation found several safety issues, including Boeing's documentation, specifically the lack of critical removal documentation or records for the non-routine MED plug work performed during production. A key Boeing business process instructions for parts removals was overly complex and had a history of compliance issues, including unauthorized removal of items. Inadequate training of personnel and ineffective change management strategies in response to a decrease in workforce experience. Incomplete closure of the MED plug without the 4 bolts. Boeing's ineffective corrective actions in response to the history of compliance issues and the FAA's ineffective oversight. Inadequate quality escape mitigation efforts, which focused on components or product conformance, should also have strategies to address the actions of people performing tasks and mitigate potential human errors. In addition to those manufacturing-related safety issues, we also found a need for review of portable oxygen bottle use design standards, flight deck door operation description in flight crew manuals, additional flight crew training with differing oxygen systems. We are also concerned about procedures and technology to preserve cockpit voice recorder audio, and the potential injury for lap-held children during a rapid depressurization. I will discuss some of these issues now. The remainder will be covered by my colleagues in their presentations. The MED plug had shifted upward over time during previous flight cycles, as evidenced by a series of parallel dust and dirt witness marks along the section of its seal contact area on the fuselage. This displacement was too small to be seen by the flight crew from the ground during pre-flight walk-around inspections. The MED plug is not visible from inside the cabin except for its window. It's hidden behind interior panels. 2 of the 4 portable oxygen bottles were used in flight. One flight attendant was unable to open the packaging without improvising a tool, her identification badge, to puncture it. This flight attendant also had trouble uncoiling the tube and donning the mask, choosing instead to hold the mask over her mouth rather than secure it. Although this particular mask, a plastic bag with exhalation holes, a metal nose strap, and an elastic head strap, met FAA design standards, the difficulties the flight attendant encountered using them suggest that the standards, the mask design, or both do not adequately consider the ease of use. Flight attendant training exercises did not include opening a sealed mask packaging. The mask type shown here and used during the accident is one of 2 common mask types. The ability for the crew to don masks quickly during an emergency is a safety issue. Staff has proposed one recommendation in this area. The potential risk to lap-held children during a rapid depressurization, severe turbulence, or loss of control is a safety issue. The NTSB has a long-standing history of interest in the safety of lap-held children on board airplanes. For more than 3 decades, we have recommended that the FAA require the use of a child restraint system appropriate to the child's size and weight. However, in response to these recommendations, the FAA has consistently declined to mandate child restraint systems usage for children under the age of 2. Staff has proposed to reiterate recommendations in this area. The accident airplane was equipped with a 2-hour cockpit voice recorder, or CVR. According to Alaska Airlines Flight Operations Manual, flight crews involved in an accident or incident were required, if possible, to pull the CVR circuit breaker as soon as the airplane was secured in order to preserve the audio. However, this procedure was not followed, and by the time maintenance personnel pulled the circuit breaker, the accident flight audio had already been overwritten. Additionally, had the airplane been equipped with a 25-hour cockpit voice recorder, something the NTSB has long recommended, the audio from the accident flight would have been retained. Staff has proposed recommendations in this area. Before I close, I'd like to acknowledge the NTSB staff who participated in the investigation. And also the parties to the investigation. Additionally, numerous safety actions were taken after the accident, some of which we will discuss here today. Up next are presentations covering the issue areas of manufacturing records, human performance, structures, and operational factors. Madam Chairwoman, This concludes my presentation, and now we'll hear from Mr. Cruz about maintenance records.
Mr. Cruz, if you can hold for a second. It is hot in here. We're going to be here for a while. So I do want to invite staff, if you want to take your jackets off. People are more interested in what you're saying than what you're wearing. So feel free, please, be comfortable. It is hot. We will be here for a while, so feel free to do that, okay?
Thank you.
Good morning, Chairwoman Homendey and members of the board. In staff's presentation, we briefly discuss the 737 manufacturing process at Spirit Boeing Renton for the accident airplane line 8789, the issues that led to this accident, and the FAA surveillance of the Boeing production certificate. The manufacture of the Boeing 737 aircraft starts at Boeing supplier Spirit Aerosystems. Spirit Aerosystems is a major supplier of 737, 777, and 787 fuselages to the Boeing company. The company is headquartered in Wichita, Kansas, with facilities in the United States, United Kingdom, France, Malaysia, and Morocco. Spirit Aerosystems manufactures several other key components, including wing leading edges, pylons, nacelles, thrust reversers, and flight deck sections for various Boeing aircraft programs. The 737 airplane fuselages, once finished, are shipped to Boeing via rail to complete the final assembly of the airplane. As part of the 737-9 fuselage build process, edge frames, located by arrows in the photograph, are first attached to the fuselage to provide structure onto which the mid-exit door or MED plug is installed. The edge frame components are manufactured by a Spirit Aerosystems supplier, QuickTech. According to Spirit production documents, the edge frames for the left MED plug were installed on the accident fuselage on June 16th and completed on June 19th, 2023. No document discrepancies were reported on the installation or inspection of the edge frames. After the accident, and upon learning of workmanship issues on the fuselage edge frames for line 8789, Spirit Aerosystems started a review of the QuickTech's manufacturing process, including inspecting all edge frames currently in production and in stock. Further, the company completed inspections of all edge frames in the Spirit production system, including fuselage in the production line. No edge frames exhibited the conditions consistent with those reported by Boeing on the accident airplane. Spirit Aerosystems has design responsibility, which includes the build standard and engineering drawings for the MED plug. The accident airplane's left MED plug was manufactured and completed by Spirit Aerosystems Malaysia on March 24, 2023. The plug was then shipped to Spirit Aerosystems Wichita and received on May 10, 2023. Per Spirit Aerosystems production documents, the left MED plug was installed on the accident airplane on July 18th, inspected and completed on July 28th. A completed installation of the MED plug required the installation of the 4 bolts to prevent upward movement of the plug. Line 8789 departed Spirit Aerosystems via rail on August 20th, 2023. In the Boeing 737-9 manufacturing build process, there are 10 factory positions referred to as flow days. A simplified version of each flow day can be seen in the graphic. Work scopes associated with the MED plugs, circled in yellow, were accomplished on flow days 1 through 3, 7, and 9. Boeing installation plans, or IPs, are installation instructions for the build of the airplane and have a baseline schedule in the manufacturing process. Non-conformance records, or NCRs, are documents that record discrepancy conditions that can be corrected and meet engineering design. The NCRs are dispositioned with work instruction documents called non-conformance orders, or NCOs. NCRs and their associate NCOs are not pre-planned work and therefore do not have scheduled flow days like IPs. During the investigation, staff heard the term traveled work. According to Boeing, there are 2 types of traveled work. First, where the built article travels from a supplier to Boeing with open work, and second, when the built article moves from flow day to flow day within the factory without the scheduled work being completed. Boeing expects an NCR will be completed on the same flow day it was generated. When this does not occur, Boeing considers this traveled work. According to Spirit Aerosystems documentation, line 8789 did not have a supplier traveled work when it was shipped from Spirit Aerosystems to Boeing Renton. Line 8789 was received by Boeing Renton and entered the final assembly process on August 31st, 2023. On September 1st, 2023, during quality inspection of the fuselage per the IP, Boeing inspectors identified and wrote up discrepancies on 5 rivet locations shown in the photograph on the forward edge frame common to the left MED plug. Boeing inspectors cited that the 5 rivets were not installed properly and needed replacement per Boeing specifications. Spirit Aerosystems manufacturing personnel stationed in Renton were tasked to replace the 5 rivets. To replace the 5 rivets, the left MED plug would need to be opened to gain access. According to Boeing procedures, Spirit Aerosystems manufacturing personnel were not allowed to open previously completed installations on the airplane. Therefore, it would be Boeing's responsibility to provide access to the edge frame. To access the edge frame rivets, Boeing manufacturing door personnel would need to open the left MED plug, which required the removal of the 4 bolts to prevent upward movement of the plug. Once the rivets were replaced by Spirit Aerosystems personnel, Boeing Quality Assurance would inspect the work, and again, Boeing manufacturing door personnel would be responsible for closing the plug and installing the previously removed hardware. The NCR and the NCO to replace the 5 rivets were signed off on September 19th, 2023. Additionally, staff reviewed the IPs, NCR, NCO, and related process documents for the area around the left MED plug on line 8789. Flow days 1 through 3 have scheduled work to accomplish IPs OK to install blankets and install blankets. IP OK to install blankets contains steps to inspect the entire installation area for workmanship discrepancies. IP install blankets contains steps to install blankets for the left aft portion of the fuselage, which included the area around the left MED plug. As previously discussed, during the accomplishment of IP OK to install blankets, Boeing Quality identified and initiated NCR documentation to replacement of the 5 rivets. The NCR rework was linked to the IP prevention and IP for being closed, preventing the IP to be being closed. Each operation step in this IP should have been short stamped. A short stamp is an application of the stamp in the paperwork indicating further work needed to be accomplished. With the paperwork short stamped and the NCR work completed on September 19th, Boeing manufacturing personnel would have had to re-accomplish all work common to the left MED plug area. Staff identified inconsistent application of the short stamp process on IP documents in the work area common to the left MED plug on line 8789. IP documentation such as the installation of the left interior sidewall panels were properly short stamped to complete the sidewall installation. Other IPs, including OK to install blankets and install blankets, were improperly short stamped or completely signed off. Staff has proposed a recommendation in this area. Per Boeing's Business Process Instructions, or BPI, titled Perform Part or Assembly Removal, opening and closing of the MED plug would have required a removal document to be initiated. After an extensive search, Boeing and the investigative group determined when work associated with the replacement of the 5 rivets were performed, no removal documentation was created as required by Boeing procedures. Why is this important in this accident? A removal document would have provided pertinent information related to the opening, removing, partially removing, loosening, or disassembling a previously installed and accepted component, part, or assembly. A removal document also ensures that disturbed installations are restored and re-inspected by Boeing Quality Assurance. The failure to generate a removal document on line 8789 resulted in an incomplete left MED plug installation in which the 4 bolts to prevent upward movement of the plug were not reinstalled. Due to the lack of the removal document, the investigative group narrowed the time frame from when the left MED plug was opened and closed during the rework process. A timeline was developed for a variety of sources, including interviews and written statements from manufacturing personnel, shipside action tracker, aircraft build records, Boeing communications, airplane entry and exit records, and photographs from both Spirit and Boeing employees. According to Boeing documents, the rework to replace the rivets on the left MED plug started on September 18, 2023. The timeline showed that the left MED plug was still in the closed position on September 18th until about 7:58 a.m. Investigators could not determine the status of the MED plug between 7:59 a.m. to 10:52 a.m. The evidence showed that from September 18th at 10:53 a.m. to September 19th at 5:09 p.m., the MED plug was open. On September 19th, from 5:10 p.m. to 6:38 p.m., investigators could not determine the status of the MED plug. Photographic evidence showed that on September 19th at 6:39 p.m., the left MED plug was in the closed position. The lack of removal documentation for the work led staff to further review BPI performed part or assembly removal. This BPI was applicable to not only the 737 production line, but also the rest of Boeing's commercial product lines. The review of the BPI revealed 11 notable revisions to the document from 2013 through 2023. During the same period, multiple quality alerts were sent to personnel to reinforce the BPI. Additionally, from 2018 to 2023, there were 16 regulatory compliance issues cited by Boeing, internal audits, and the FAA. In each of these cases, Boeing had initiated safety risk management activities using the Boeing problem-solving model to identify the root cause and potential changes to the process. It was evident to staff that past safety risk management processes regarding this issue were ineffective due to the repetitive findings for this BPI. Staff has proposed recommendations in this area. As part of the investigation, staff conducted a review of the FAA's surveillance of the Boeing production certificate. Each year, the FAA develops a certificate management plan to assist the principal inspectors in planning and tracking the performance of ongoing certificate management responsibilities. A risk-based resource targeting assessment tool was used to assign risk to production holders according to the likelihood that it would produce non-conforming products, articles, or parts. FAA management then developed a certificate management plan for each inspector using the Aircraft Certification Audit Information System. Interviews with the FAA inspectors revealed they were unaware how risks were assessed to determine what additional relevant audits were required in the surveillance of the Boeing certificate. The FAA's compliance enforcement program allows production approval holders to self-disclose their violations, other safety discrepancies to the FAA, and to promptly take corrective actions to prevent future violations. Per the FAA Records Management Order, records of these safety discrepancies were destroyed at the earliest 5 years after closure. Staff determined there was a high probability that historic systemic non-compliance issues were not accounted for when developing the next fiscal year's surveillance plan for the Boeing company and its suppliers. As previously discussed, repetitive systemic issues with BPI performed part or assembly removal have been ongoing since 2018 across all Boeing manufacturing lines. Staff concluded that the FAA's compliance enforcement system, current surveillance process, procedures, and recording systems were not effective in identifying repetitive and systemic discrepancies and non-conformance in the Boeing production system. Staff has proposed a recommendation in this area. This concludes my presentation, and Dr. Woods will now discuss human performance issues in this accident.
Good morning, Chairwoman Homendey and members of the board. I plan to briefly discuss Boeing 737 manufacturing personnel experience levels, door manufacturing personnel at the Renton factory, door technician training, and Boeing quality and safety management systems specific to the accident airplane. In 2018 and 2019, following two 737-8 MAX accidents, a decrease in 737 production necessitated the reallocation of personnel and effectively halted hiring. The subsequent global pandemic saw the loss of even more production personnel, particularly among those who were retirement eligible. In 2022, when Boeing sought to increase production back to pre-2018 levels, they also increased hiring. Many of the personnel that were hired came from non-manufacturing sources, resulted in Boeing having a production workforce that had less manufacturing experience than before. Boeing did not conduct a change management or risk assessment on the changes in the workforce and therefore missed the opportunity to identify the risk associated with having a relatively inexperienced production workforce prior to their introduction to the factory floor. At the time the accident aircraft was in production, 737 door manufacturing personnel at the Renton factory consisted of 1 manager and 24 technicians. The technicians were typically divided into 2 teams named the door crew and door masters. All door personnel typically worked first shift Monday through Friday. Door crew would typically work flow days 1, 2, and 3, while door masters typically worked flow days 7, 9, 10, and the ramp areas. All door technicians, regardless of assigned team, were responsible for functional and operational checks and troubleshooting for all door systems. Staff reviewed Boeing's training program specific to the door personnel. All newly hired production employees were required to attend and pass a proficiency check for their initial foundational training before going on to their job series specific on-the-job or OJT training. At the time the accident aircraft was in production, Boeing did not require a task list, grading structure, or training documentation for the OJT. The OJT program often relied upon the expertise of the more experienced to train the less experienced. For door manufacturing personnel, OJT would have focused on performing routine tasks required for every build. Non-routine tasks, such as the removal of an MED plug, did not offer many opportunities for training due to the task's rare occurrence. During the window the left MED plug was determined to have been opened, there were 4 door personnel identified as having worked on the accident fuselage. All 4 had less than 2 years of experience working 737 door systems. Staff has proposed recommendations in this area. Quality management sets the standards by which a part or component is to meet its regulatory certification requirements and the needs of the customer. According to their quality manual, Boeing's quality management system was the organizational structure, processes, procedures, records, and resources needed to integrate, document, implement, and maintain the various components of an effective business system. Boeing's production certificate contained their authorization to manufacture type certificated products and was audited in 2023 by the FAA. Boeing's QMS manual defined a quality escape as a product or article that did not conform to its approved design and had been released from the quality system. The quality escape section of Boeing's QMS described how to identify, control, document, and disposition a product that did not conform to specifications, regardless of whether the non-conforming product or service was generated internally, received from an external provider, or identified by the customer. However, the manual did not specifically address escapes that were the direct result of human error, nor did it provide guidance for human factors analyses. Staff has proposed a recommendation in this area. A safety management system is a systematic, proactive approach to managing safety risks within an organization. At the time of the accident airplane's production, there was no regulatory requirement for Boeing to have an SMS. However, in December 2015, the FAA had required Boeing to create an SMS as part of a settlement agreement developed to address multiple alleged quality and certification lapses. In December 2020, the FAA accepted Boeing's Voluntary Safety Management System, or VSMS, and it became operational in June 2021. According to Boeing's VSMS manual, the program's goal was to identify, assess, and control hazards and mitigate risks based on a thorough understanding of the systems, processes, human factors, and operating environment. On April 26, 2024, the FAA published its final rule requiring production certificate holders to implement a regulatory SMS. The rule became effective May 28, 2024, with most organizations, to include Boeing, required to comply within 36 months. An SMS is composed of 4 pillars: safety policy, safety risk management, safety assurance, and safety promotion. At the time of the accident, Boeing had not yet fully implemented its VSMS to the Boeing 737 production level, but was working to integrate SMS principles into its QMS while awaiting the FAA's final rule regarding SMS for manufacturing. This integration included having identified the need for and commencing 2 different safety risk management assessments on technician training and the ongoing issues with the removal process, respectively. The SRMs had not yet concluded at the time the accident occurred. After the accident, and in response to a request from the FAA, Boeing developed their product safety and quality plan that identified 6 key performance indicators of production health that would trigger future SRMs should the indicators fall outside their respective control limits. None of the factory-level personnel NTSB staff interviewed were able to describe what an SMS or hazard identification was, what Boeing's safety policy dictated, nor could they define safety culture. For there to be continuous improvement at Boeing, production line personnel must recognize their shared responsibility in supporting a positive safety culture and identifying hazards and risks. Feedback about safety culture elements was a mix of positive attributes, such as technicians saying they were comfortable taking issues to their managers and were never being pressured to do something they did not know how to do, and negative attributes, such as concerns over being labeled a troublemaker or being reprised against for bringing up problems. Most of the technicians had knowledge that various reporting platforms, such as the Speak Up program, existed, though few used them, preferring to talk to their immediate supervisor instead. Data was only collected from the individuals who were selected as possibly being able to contribute information specific to the accident investigation. The NTSB originally decided to initiate the development of a survey to perform a more robust safety culture assessment. However, 737 production was effectively halted due to a work stoppage in late September 2024. In December 2024, staff further determined that the results of any survey conducted at this point would not give an accurate depiction of the safety culture that existed in September 2023 when the accident airplane was being manufactured. The combination of this fact and due to the ongoing work stoppage, it was therefore decided against administering the survey. Although the NTSB was unable to methodically assess whether safety culture elements may have affected the production of the accident airplane's fuselage, the NTSB remains concerned about the impact affirming a positive safety culture has on identifying potential hazards and building effective risk mitigations at Boeing for the future. Therefore, staff has proposed a recommendation regarding this issue. This concludes my presentation, and now we will hear from Mr. Cruikshanks discussing structures.
Good morning, Chairwoman Homendey and members of the board. My presentation will discuss the airworthiness directive issued by the FAA after the accident and post-accident changes to prevent future mid-exit door plug departures. Immediately after the accident, on January 6, 2024, the FAA issued an emergency airworthiness directive that prohibited further flight of all Boeing 737-9 airplanes equipped with MED plugs until those plugs could be inspected and any discrepancies corrected. Results from the inspections showed that all airplanes inspected had plugs that were correctly engaged with the stop fittings, and the 2 upper guide track bolts and 2 vertical movement arrestor bolts were installed. As a temporary solution for in-production airplanes, the FAA approved a multi-airplane non-conformance record on March 1st, 2024, to incorporate the AD inspection procedures on airplanes in the factory. At the completion of the inspection, an entry was made in the logbook to document compliance with the AD. As a permanent solution, on November 4th, 2024, the FAA approved 2 Boeing installation plans, or IPs, one each for the left and right MED plugs. The IPs added an inspection procedure in the factory to ensure that the 2 upper guide track bolts and 2 vertical movement arrestor bolts were installed properly. Incorporation of the IPs on the production line complies with the AD and becomes part of the type design of each airplane. Since the accident, Boeing and Spirit Aerosystems have developed a design enhancement for installation on all MED plugs. The design enhancement adds a secondary retention device to the forward and aft sides of the plug below the 3rd stop fitting from the top at locations 1 and 2. The hammer-shaped secondary retention devices must be rotated into position when completing the installation of the plug and would engage with the fuselage stop fittings, preventing vertical translation of the plug. The design of the retention devices would prevent installation of the cabin sidewall panels unless the devices were properly engaged. Additionally, lanyards would be installed on the 2 upper guide track bolts at locations 3 and 4, and the 2 vertical movement arrestor bolts at locations 5 and 6 to permanently secure the bolts to the plug. The bolts with lanyards will provide a visual indication that they are not installed. As of June 2025, the engineering for the design enhancement has been completed, and Boeing and Spirit are continuing certification planning and compliance work that includes notification to the FAA. Once the enhancement is certified, Boeing has stated that they will be installed on all new production airplanes in the factory, and a service bulletin will be issued to retrofit the fleet. Staff have proposed recommendations in this area. This concludes my presentation. Next, Captain Blum will discuss operational factors.
Does anyone need a break after presentation?
Good morning, Chairwoman Homendey and members of the board. My presentation will discuss aspects of operational factors that affected this accident, including flight crew performance, differences in the audio control panel, flight crew training, and Alaska Airlines post-accident safety changes. The crew verified the pressurization was normal while climbing through 10,000 feet. While passing through about 14,800 feet, the left MED plug departed the airplane and the cabin depressurized. The crew described it as an explosive and chaotic experience, stating it was very loud and difficult to hear each other or air traffic control, ATC. The crew promptly proceeded with the memory items on the cabin altitude warning or rapid depressurization checklist, which were donning their oxygen masks and establishing communications with air traffic control. They turned up the volume for the overhead cockpit speakers to hear each other and ATC. The first officer reached for the quick reference checklist, which was not in its holder, so the captain placed the quick reference handbook on the glare shield panel for the first officer, who continued the checklist. The captain began a descent while the first officer ran the checklist and communicated with ATC. The crew heard the interphone chime, and the captain tried to communicate via the cabin interphone with the flight attendants. He reported hearing the flight attendants talking about a hole in the cabin. He attempted to communicate multiple times, but was unsure if they could hear him. One of the flight attendants reported he heard a pilot state the flight was returning to Portland. Around 10,000 feet, the crew took off their oxygen masks and put their headsets back on. They reported a squeal in their headsets, making it impossible to communicate to each other or ATC. The crew took off their headsets and redonned the oxygen masks throughout the approach and landing. The flight crew's response to the emergency was timely, and they landed the airplane uneventfully and safely. Pilots receive hands-on emergency equipment training for the 737-9, -8, and NGs during continuing qualification simulator events every other year. This picture shows the 2 types of oxygen stowage boxes and oxygen masks in the mock-up trainer located in the simulator facility. The top oxygen stowage mask box Circled in blue is the one present on the 737-9. In the 737-9, when a pilot pulls the mask out of the stowage box, the oxygen mask microphone is enabled automatically. To reestablish communications with the headset after taking the oxygen mask off, the right door on the stowage box must be closed to stop the flow of oxygen, and the test reset switch, circled in yellow, must be pressed to disable the mask microphone and enables the headset boom microphone. In the Boeing 737NG, there is a mask boom switch, circled in yellow, on the audio control panel to enable either the oxygen mask microphone or the headset microphone. This switch is not present on the 737-9 audio control panel shown on the left. The crew did not shut the right door or depress the test reset switch after removing their oxygen masks. The crew said they instinctively reached for the mask boom switch. Both pilots had more flight time in the NG than the 737-9. Both crew members had one rapid depressurization training event in the simulator during initial training, which was 17 years prior for the captain and 3 years prior for the first officer. When the 737-9 was first delivered to Alaska Airlines, each pilot completed a computer-based training module on oxygen mask systems and communication differences from the NG. As mentioned earlier, pilots receive hands-on emergency training every other year during the continuing qualification simulator evaluation. The captain had the hands-on training 9 months prior, and the first officer 11 months prior to the accident. Staff has proposed one recommendation in this area. Since the accident, Alaska Airlines has made several safety changes. They have updated language concerning oxygen masks and communications in their manuals. They have updated language in their manuals and checklists to remind crews, the flight operations duty officer, dispatch, and maintenance and engineering to pull the CVR and FDR circuit breakers. They have also made several training enhancements to include improved computer-based training slides, a video reenacting a rapid depressurization. They issued a bulletin to all instructors, making communications an emphasis item during training and checking events, and a 2025 simulator training event for all pilots that includes a rapid depressurization requiring reestablishing communications. This concludes my presentation. Thank you.
All right. You're good?
Madam Chairwoman, that concludes staff's presentations, and we are now ready to answer your questions.
Thank you. Thank you so much, Mr. Brazy, Mr. Cruz, Dr. Woods, Mr. Crookshanks, and Captain Blum, certainly for those excellent presentations, and thank you to the entire staff for your work. We are going to turn to board member questions. Before I do that, after this first round of questions, we're going to take a brief break. We'll come back for the other rounds of questions. Just for the audience, at some point later, we'll have just to set expectations, we will have a lunch break if we continue, and then we'll have more breaks as needed. Staff should feel free to text if you need a break that is not already anticipated. All right, starting with board member questions focused on the major safety issues we identified in this investigation. In the first round, we'll discuss structures to include the mid-exit door plug, not the design enhancement. We're going to talk about that under safety changes. But we'll talk about structures, including the mid-exit door plug. We'll talk about cabin pressure controller and the flight deck door, with that, I'm going to start with Member Graham.
Thank you, Chair. I want to commend the staff for the great work on the investigation and the draft report. Let's start with the movement of the plug prior to the accident flight. Can you explain how the team determined how much the plug was moving and everything it used to determine that it was moving?
Mr. Fox will answer that question.
Yeah, we did a look made a careful assessment as we were examining the components. Initially on the airplane itself, we were looking at the stop fittings and looking at damage patterns on those stop fittings that indicated that the plug had moved upward and was translating outboard. And then once we found the plug, we found corresponding damage on the plug itself that made it up to that damage that we saw on the frame. So that told us how the plug was moving up and moving outboard. And then we also, as we were examining the plug, we found some indications of linear features. Yeah, if we can pull up the backup slide, the earlier one. Yeah, the first one. That's the one. So at the top end of the plug, where the seal contacts the plug, you can see those multiple lines of that going across the surface there. That's an indication that the plug was moving up over time. That's a combination of dirt and petroleum jelly that's used as a lubricant on the seal. And so as the plug was moving up, it'd leave a little trace of dirt at the upper edge of the seal at each of those positions as it was translating upward. So that's our indication that it was happening a little bit over time.
Great, thank you for that. Was there anything we got off the quick access recorder that helped with this?
We asked, excuse me, we asked Boeing to take a look at the 9 flights that were on the QAR, and they performed a dynamic loads analysis on the plug structure. We weren't really able to determine. We found a couple of flights where it may have moved, but there wasn't a real good indication of that movement over time, only because we had 9 flights.
Great, thank you for that. That's great work. Let's talk about the bolts on the plug. It was determined that even one bolt properly installed would have prevented the mid-flight separation of the plug. Is that correct?
Yeah, again, Boeing, we asked them to do an engineering evaluation of the design of the plug, and that evaluation determined that one of the vertical movement arrestor bolts on the lower part of the plug, one of them would hold it in position, or both of the upper guide track bolts would hold it in position.
Okay, so why was it designed for 4 bolts then?
Redundancy.
Redundancy, correct. That's why we have a great safety record in aviation, because of redundancy and training. At the time of the accident, or after the accident, did we determine, the AD went out, were all the other 737s that were inspected, did they all have the bolts in place correctly?
The AD showed that every airplane had the bolts installed. Some of them had an incorrect number of washers, some of them had an incorrect torque on some of the bolts, but the bolts were installed on every other airplane.
They're all installed. Do we know how many aircraft that was? Roughly?
I don't recall off the top of my head. I can find that.
Okay. Since this was delivered without the bolts, according to what the team has presented here, at what point would Alaska Airlines have determined that the bolts were missing? What inspection or anything else, maintenance, would they have been able to find that the bolts were missing?
The maintenance program has the first inspection of the plug at 24 months and then a repeat interval of 24 months. So it would have been 2 years before they would ever open that to look at it.
2 years.
Correct.
Okay. Thank you, Chair.
Thank you. Member Chapman?
Thank you, Chair, and thanks to all of you for your outstanding work on this complicated investigation. Mr. Crookshanks, I think this one goes to you. After examining the door plug, how was it determined that the bolts were missing at the time the plug separated from the aircraft?
Well, I can address that from the materials laboratory examination. We took a close look at the bolts, the holes where the bolts should be installed, and we can bring up the backup slide there. And initially on some of the bolts we saw, or around the bolt holes, we saw some indications of oily deposits on the surface mixed with dirt. Indication that there had been something installed there at one time. Like the edge, it was circular, like the edge of a washer. However, it washed right off once we applied an ethanol clean to it, and then once they were clean, the holes were pristine. There was no indication of any kind of bearing contact damage that would say that a bolt was there and broke as a result of the process. There was also no sign of any wear or indication that a bolt had been working loose over time. That was another thing that we looked for. And in the end, we had this, and maybe the next slide as well, where we have the upper guide track bolt hole. And you can see the hole's intact. There's no way a bolt could have been installed in there unless it broke or was never installed. And the condition, we looked closely under the microscopes just to make sure. We also did materials analysis to check for any kind of transfer marks or anything, material transfer to the remaining components, and there was no evidence of contact with those bolts.
Thank you. That's helpful. Sort of looking at the same question, but from the opposite side, how was it determined that the bolts had in fact been installed at one point?
So we had a couple things. The first thing was that there were some faint material, I would say like a greasy material that matched the outline of the washers that we'd expect to be there, and we saw that initially. And then we have the photographic evidence that once the part arrived at Renton facility, we have photos showing that, and in those photos you can see that the hardware was installed at that point.
Thank you. And we were told here just in response to Member Graham's questions that fewer than 4 bolts would have been sufficient to hold the plug in place, correct? In fact,
Yes.
Possibly as little as 1 bolt would have been enough.
Correct.
And without the bolts in place, what kept the door plug in place and prevented it from separating from the fuselage sooner?
Maybe I'll let Mr. Cruikshanks talk about that.
So the plug was engaged with 12 stop fittings around the periphery, and while the airplane was pressurized, it was being pushed out against those stop fittings, so it wasn't able to move when it was pressurized. For the parts of the flight that were unpressurized, it was simply the friction between the stop pads and the stop fittings.
And those fittings essentially fit over each other like this, and what was happening is it was gradually moving up, and eventually it wouldn't hold it any further. Is that correct?
That is correct, yeah. We saw the evidence of that in the materials lab exam and those seal marks. And we know that it moved incrementally up over time until it got to an instability point and was able to pop out of the fuselage.
Great, thank you. Chair, I have one additional question in this area. I'll save that for the next round.
Great, Member Inman.
Great. If we could ask the operator to bring back up slide 41 of the staff presentation. Now everybody's reaching for it. Wanted to know which one it was. This is the timeline of the MED plug. And I'm curious because we saw this just a little bit after our staff meetings. Or on the final slide, it looks like the text there says, "All done. Train your team to do these small installs." What was that correspondence and what was it about?
Member Inman, that correspondence was between the installation manager and the interiors manager, and the interiors manager, after the plug was confirmed closed, had asked the installation manager to have some of his folks travel down to float A10 from float A1 to restore the insulation back over the MED plug.
And so that correspondence was only, so what were they asking to train their team about?
Installing just a few pieces of insulation rather than pulling people off of float A1 who were installing the insulation throughout the entire airplane. They didn't want to have those people stop to walk down to float A10 to put three or four pieces of insulation in place. He was just saying, train your people to do it, so I don't have to interrupt my folks.
Is this anything typical we found that they're teaching? I guess I'm kind of concerned. In a text message, one team is telling another team to train their people to do something. That doesn't sound like a documented process.
It is not.
Okay, thanks. I'm going to go on to just about door plugs in general, and I know we touched on this a little bit during the hearing. We found through this investigation that most of the Boeing personnel were unfamiliar with the process of removing and installing a MED plug. Why are we putting MED plugs into airplane fuselages?
They're a alternate method to close a hole that would have been occupied by an emergency exit for seating configurations that don't require that emergency exit. And it's a customer option. They are less complex, they weigh less, and they require less maintenance.
So, but why is the hole in the fuselage to begin with then?
To provide an emergency exit function for airplanes with enough seats that need an additional emergency exit beyond the ones that are already functional.
So is it right to assume that they're manufacturing the fuselage so that they can use a more standardized fuselage and just sell it to different customers based upon what they want?
Customers can choose whether they want to have those exit doors functioning or not, and it's usually based on seating configuration, which would dictate whether or not an additional exit is required or isn't.
And it sounds like it's also in order to make sure it's still within the certification, the original certification of the plane? Does that make sense?
So maybe I can help explain this. The 737-9 fuselage can be certified for several different passenger seating configurations. Once you get above a certain number, I think it's 179, you have to have additional emergency exits on the fuselage. So Alaska Airlines does not buy that option. They have a much lower seating configuration than some other airplanes. So they decided to choose the plug option, which plugs that hole, doesn't use as much weight, not as complex. There's several other airlines that also have a plug, United, Copa, Aeromexico.
I guess the question is, why is it safer to manufacture one fuselage with holes in it and then plug it, or another fuselage that just has emergency exits?
The fuselage itself is the same length, and so you've got to have those openings there in case you want that more dense seating configuration.
It gives you an opportunity to sell more airplanes to more people.
Yes.
That's kind of the point I think I was getting to.
Yeah. One fuselage, you can sell it as a couple of different configurations.
In every different configuration you put in, you can inject additional risk into the manufacturing process. And I think we've saw that.
I don't know that we have an exact answer to that question.
It's okay, Doug. You don't have to. I think I'm out of time for this round.
Thank you. Mr. Cruikshanks, the investigation found the airplane had experienced how many flights at the time of the accident where you determined where the door plug was expelled?
The aircraft had accrued 154 flights when the door plug popped out.
Okay, thank you. Mr. Fox, you talked about your analysis, but not a lot of people in the public have visibility to equipment and what we do in the lab. So I was hoping you could take a little bit of time to talk about your very in-depth process. I think there is often afterwards a expectation that you'll know in 5 minutes whether there were bolts there or not, but it is a a very meticulous process, and I want to make sure people appreciate that. So if you could really talk about the expertise of our Office of Research and Engineering, what you have in the lab, along with, I can't leave out Mr. Cruikshanks and Leani here, who isn't with us today. She's out of, not in DC today. But if you can talk about that, I think that would be helpful, including our equipment and needs.
Sure, I can talk to that. It's definitely a process, and the more experience we have, and having experienced people involved in the process definitely helps to identify key features and things of interest. Initially, the visual examination's really an important step in the process, and having an experienced set of eyes, looking for anomalies, things that are different, or looking at those witness marks and things where items are maybe contacting in areas they shouldn't be, and identifying where those are and getting those all documented. Then we move on to the photography documentation there. And then we start looking at things at higher magnification. Initially, with on scene, we're using loop microscopes or magnifiers and things of that nature. Once we get it back into the lab, we have better equipment for doing microscopes and getting optical magnification that way. Then when we need to go to the next level, we're looking at our scanning electron microscope, where we can get magnifications up to 1 million times magnification if we need it. We can also use that same equipment to analyze the composition of the materials, and if we see material transfer, we're looking at closely at those surfaces to give indications of what different materials might have moved against each other, give additional clues to how things came apart. And then we have also equipment for developing 3D models. And we employed that when looking at the hinges. We noticed that the lower hinges were bent, and we used the 3D scanner to scan that and measure that bend angle in those hinges. And that all came together to show that, yes, this is all damage consistent with the door plug moving up and outboard in the course of the separation and decompression event.
Great, thank you. And I'm going to come back to you in another question, another round, but Mr. Cruikshanks, how was it discovered that Boeing's written system description was wrong on the design production instructions for operators?
I believe NTSB staff found the system's description manual had a typo in it. It was calling for pushing the plug up versus down, and we brought that to the attention of Boeing, and they made a pretty good change quickly to the AMM, and then later that went down into the system's description.
Great. And how about the MOM, the multi-operator message that was in development? I know that there were a number of versions. Did you review the MOM that Boeing sent out? Were there issues?
We did review that, yes. That was an iterative process there right after the accident between the FAA and Boeing, because the FAA had issued the airworthiness directive. Boeing was writing the instructions and working with the FAA to make sure that their instructions would comply with the intent of the AD. And through our party process, we were part of that as well. So all of us were looking at the MOM.
Great. Thank you very much. Member Graham.
Thank you, Chair. Besides the damage to the MED plug frame and the plug itself, was there any other external damage to the aircraft?
There was a scuff in the paint after the door, and there was a marking on the leading edge of the left horizontal stabilizer where it looked like a piece of paper or a piece of documentation had struck it. It did not dent it, it just made an impression, an ink impression on it.
So we were fortunate the plug didn't strike the left horizontal stab or some part of the tail section?
Correct.
Correct, thanks. Let's move to, I see we can talk about the cabin pressure controller and the flight door here. So the flight deck door, let's move to that here for a second. When did Boeing go to the flight deck door as a pressure relief device?
The first time was about 2002. There are other models. This is not on the 737 MAX, but there are other models that used the door as a decompression device, and they were starting around 2002.
Okay, so when did the 737, which derivative did this go to? Is just the MAX?
Correct. During the certification of the MAX.
Okay, and I believe we found out that there was no information provided to the airline in any of the manuals about this?
That is correct.
That is correct, okay. Since we've got pressure controllers, let me move to that here. There's been a lot of discussion out in the public and the press about the auto fail light coming on, especially the previous two flights to the accident flight. Can the team talk a little bit about what they found with the auto fail light and the conclusions that you've drawn from that?
We can. Mr. Hooray can address that question.
Yes, the auto fail light was caused by an intermittent failure within the CPCs, which is the cabin pressure controllers. And we were able to determine through looking at recorded data that these were unrelated to the accident event.
Do we know what failed?
We do. There was a microchip failure. It had an intermittent failure, and it was basically causing a data transmission error within the unit.
Okay. And there are two cabin pressure controllers, correct?
Yes, that is correct. So if one cabin pressure controller were to fail, then the other one will automatically take control of the pressurization of the aircraft. And then even if that second one was to fail, it is a triple redundant system. The third layer of that being the pilots can now control manually the system without any cabin pressure control input.
And these controllers alternate each flight, who's in control and who's in the backup, is that correct?
That is correct.
And this, I would assume, is a very common design now for most Part 25 certified aircraft?
It is. Well, it's on all MAXs. I believe the same system is on the NGs. It's the same controllers are used on other
it was
versions
on
of the 737.
business aircraft that I flew, also on newer ones like that. Okay, thank you for that. That's all I have in this section.
Member Chapman.
Thank you, Chair. Just a couple of clarifying questions in this area. Turning back to the customer choice of a full exit door versus a door plug, that sort of customer choice is not unusual in terms of a big, complicated aircraft like this. I think there are numerous, probably physical choices that are made, but also choices made with respect to avionics and that sort of thing, correct?
Yes,
Yes,
there are
sir.
several options that the airline can choose for their particular airplane.
And with aircraft, as with a family automobile, it's common, I'm certain, for a standardized frame, essentially, to be capable of being modified for various configurations, and that's what we're looking at here. We have a hole in the standardized fuselage that is closed in a couple of different ways, depending on what the customer choice is.
That is correct.
Thanks. This question, I think, is a little unfair, probably beyond the scope of the investigation, but if there happens to be an answer, it would be helpful. This has to do with the flight deck door, using it as a pressure relief mechanism. I believe you indicated that was around 2002 that was introduced in Boeing.
That's correct on the first Boeing aircraft, but the 737 was during certification of the MAX.
Okay, so this would have been in the wake, this would have been subsequent to the September 11th attacks. And of course, we devoted a lot of resources into hardening the cockpit doors after those attacks. Am I correct in assuming that that would have been coordinated in some fashion with TSA or DHS to ensure that they essentially had signed off on that sort of a design?
That's correct. The doors meet all of the current security standards that are required by the
Okay,
door.
great. That's helpful. Chair, that's all I have in this area.
Thank you. Member Inman.
So in our original discussion, we talked about 10 team members on the door team and then a door team leader, I believe. And in the interviews and transcripts we have, specifically, I think it was said that the other 14 door team members, that they had one person that was the most knowledgeable and relied on them to provide direction for door plugs. But none of them have ever opened an MED plug. Is that accurate?
So the one gentleman who had acknowledged that he'd opened an MED plug multiple times was on vacation and I think literally out of the country at the time this plug was open. Every other person we interviewed and or got a written statement from denied having any knowledge of previous or how, knowing how to open it or any previous training on how to open the MED plug.
So I think we outlined, was there 20 people on the door teams?
24 total.
24 people on the door teams, and one person who's out of the country on vacation is the only one that's ever opened one?
That's what we were told, correct.
Okay. I'll go on to the CPCs for a moment. I think Member Graham brought up a good question about the faults that had occurred. And I think it was, as I understand it, this is an asynchronous chip that is installed, that basically there were 10 failures in the past, or that we had noted on typical sequences that had occurred where the auto fail light had illuminated. Is that right?
Yes, that's correct. There was a specific signature in the fault codes that we were looking for in the memory of the cabin pressure controller, and we found that on 10 other units.
So in the footnote, it was kind of interesting because it was buried into a footnote, but we found that on those 10, but that was out of 585 CPCs that had been repaired within 2 years?
Yeah, I think it was within 3 years, which I think worked out to be about 200 a year. But to put that in context, there's over 10,000 of those units that are in service. So in that sense, it's a fairly small percentage.
But it's still 580 or 500 over 3 years that are needing to be repaired. Is that I know it's not within the scope of the investigation, but is that systemic for, I know it's a small percentage, but it seems like anyone that would fail would be a problem.
So, I mean, components fail, right? And that's part of it. And so what we look for is a system that can accept a failure of a unit. And in this case, because it is a triple redundant system, we can accept failures of one component of a CPC. It can fail, the other one automatically takes control. And there's, no issue to the crew. It's honestly probably more of a maintenance concern than it is of a safety concern.
But in this case, the maintenance had not been able to be done for that aircraft in question?
No, the maintenance was done, and in fact, every time there was a auto-fail light, the system had taken off with the system being operational. You cannot take off if the system is not operational. You would have to MEL that system.
MEL being?
You would defer it per the minimum equipment list, which is what MEL stands for.
And so if the CPC fails and is not activating, it can't take off?
Actually, you can. The FAA will allow it to take off with one CPC that's not working because you can defer it per the aircraft's minimum equipment list.
But with both failing, you could not take off?
I'm not sure. I'd have to look. I mean, you can still control the pressurization system because you can do it manually. I don't know if the FAA allows you to do that, though.
Okay, that's all I have in this round right now.
Thank you very much. After the accident, there were a lot of questions about work performed at Spirit on the airplane related to the installation of the Wi-Fi system. Was the door plug open during that type of work?
While the airplane was at AAR, they did not open the.
Oh, at
the-
8 a.m.
Yeah, they did not open the mid-exit door plug.
Great, thank you, and thank you for clarifying that it was at AAR. The flight deck door on the accident plane was designed to open and relieve pressure in the flight deck. That design serves a safety purpose, but what was missing here is something critical. Communicating that design to the operator, in this case Alaska Airlines, and to flight crews is essential for also ensuring safety. Why is that critical?
It's critical because pilots should know the systems of their airplane and what to expect.
Yep, and Alaska Airlines did confirm to us that they were unaware. Were the flight crews aware?
No, they were not.
That's important
Yes, it is.
for both cabin crew and the flight deck crew.
Yes, it is.
In this case, one flight attendant was injured when it flew open. Did Boeing give a reason for why they did not provide information on the design of the door to the operators and crew?
In a response, they said that the FCOM was based on the 737NG, and when they created the MAX FCOM, they neglected to add the new procedure, or the system function. The crew procedures remained the same, but they did not update the system description.
Right, and they also cited at one point security reasons, and then we had or at least I had a conversation with TSA that was not confirmed by TSA. This is not the first time Boeing has made design changes without ensuring the operator and flight crews fully understand those changes, to evaluating potential flight crew responses in the design certification process and evaluating what could happen if a door blows open and putting in place measures to mitigate any potential hazards. Can you give us a brief overview of Boeing's procedures for when they make a design change to an aircraft within their fleet, understanding this was changed earlier, that needs to be brought to the attention of operators and their flight crews?
Yeah, typically, when a change is made, Boeing has many different manuals that they can update depending on what that change is to communicate that change to the operator. In this case, with the door, they should have updated the FCOM, which is the Flight Crew Operations Manual.
And do you know if Boeing evaluated the effects of changing how the door plug, the flight deck door performed in this particular model or the previous model in the certification or production before the change was actually put in place?
So they did some testing. They did laboratory testing, more on the side of functionality of the door to make sure that the door lock mechanism was working properly. But that's the only testing we're aware of.
So no full-scale tests or worst-case scenario and how a flight crew would respond or a cabin crew would respond type testing?
I'm unaware of any testing like that.
Okay, great. Did Boeing, and they did not ensure the manuals or other materials were updated, but now those are updated, correct?
Correct.
Okay, and one last question for Mr. Fox. On June 18th, an article ran on NTSB's intranet, which I thought was excellent, Colleen, entitled Under the Hood Series, How Do We Find Things?, which states, every successful search begins with coordination, bringing together the right data, tools, and experts to act quickly while the trail is still fresh. I do want to thank Colleen for her work in writing the article and her work and the help from the Office of Research and Engineering. Not a lot of people understand how we find things very quickly. I will tell you, being the person who was at the press conference, when I announced what neighborhood it might be in, I feared for that neighborhood and the onslaught of people that would be in it looking for the door plug. But Mr. Fox, can you talk about how we go about calculating, modeling, and using data to narrow the search zone? I think that's not something a lot of people understand, and it is a lot of work. I will put in a plug for Bob's class one more time, who we visited while we were on scene, and Bob has since retired. That was the Catlin Gable School. But if you can talk about how we do that.
Sure. It can be a complex process that is a multidisciplinary effort from engineers, meteorologists, drone pilots, and search teams throughout the process. When something happens in the air, parts can be scattered across miles, and so we need to be able to focus our search and identify areas where items of interest are most likely to be found. So we start with a ballistics analysis, calculation that includes factors such as altitude, airspeed, an incline angle relative to the initial separation. And then to understand the trajectory of those parts as they fall, we're looking at factors such as mass and shape of the part that can affect that trajectory. We get meteorologists involved. They're looking at the winds aloft and giving us that data because those will affect how those parts fall, especially aerodynamic parts that are lighter weight. The wind can carry those. And then in this case, the MAD plug, it has a relatively large surface to volume ratio, so that also gets affected by the winds aloft. Once we do those calculations, it kind of gives us a probability plot of where to focus our search. And then we can get drone pilots involved. We have a drone program. We have 10 pilots that are trained in addition to their normal jobs. They're also out searching overhead, visual scans, and they also can do infrared imaging, which, as parts heat up in the sun, the infrared imaging can help spotlight those parts as in the search. And then eventually we got to get boots on the ground, eyes, in the field, looking for those parts and gathering them up. So we do, have search parties and search patterns that we go with there. And then, of course, the public, they're key, often finding those key parts. It might be months later that a farmer finds something in their field, as they're, harvesting. So we definitely, especially when things are landing in populated areas, we definitely encourage the public to let us know if they find something. They may have found that key part, and in this case, the MAD plug. Before we even finished all the refined calculations, we had a call.
Thank you very much. I will also say thank you to the public on behalf of all of us. After accidents, we often have public participation in helping us, which is why we often ask for people to send in things to witness@ntsb.gov, and just really thank them for their efforts because they are a key partner in our investigations as well. Member Graham, do you have additional questions here? Member Chapman, Member Inman. Okay, we're going to move on to the second round, but before we do that, we're going to take a 10-minute break. We'll come back at 11:25 and begin our second round of questions that are going to focus on manufacturing, human performance, including training and SMS and QMS, and we're going to talk about FAA oversight of Boeing and related safety actions and needs. Thank you. begin the second round of questions, and we're going to cover in this section. And just so you know why we do put these in sections is to actually enable the public to follow along with the discussion, because there is a lot. When we do an investigation, and we want to make sure that the public can follow along in certain sections. So this second round will cover manufacturing, human performance, FAA oversight of Boeing, and related safety actions and needs, which will include discussion of the design enhancement to the mid-exit door plug. We're going to start with Member Graham.
Thank you, Chair. I'd like the team to explain a little bit the structure of how the FAA Certificate Management Office conducts oversight of Boeing, as in things like where are they located, what does their oversight entail, and how many inspectors were assigned to Renton at the time of the accident?
Member Graham, the oversight plan is an annual plan that is developed. There's a risk assessment that is done on the certificate holder, or the production certificate holder. For Boeing, that is always going to be a one high, and the reason it's always going to be a one high is because they produce greater than 100 aircraft a year. So I don't foresee ever there being a scenario where Boeing doesn't produce at least that. So because of that, that requires a minimum of 18 audits be performed on site per year, and that's not limited to any one facility, that's in general. The FAA does far more than that, quite frankly. They do in pretty close in the 50s is what we saw for the 2024 calendar year when we asked during interviews. In addition to that, every 2 years they do a certificate audit, so they look at the basis for the certificate, for the production certificate, in addition to the 18 that they perform, a minimum of 18 they perform annually. The one thing I will say is there is not clear definition based on our interviews that there's a defined work scope. In other words, they kind of get to figure it out as they go and look at what they want to look at, as opposed to, let's say, an air carrier where they have very prescriptive inspections that must be performed that cover the entire certificate. So we did not see that in the production side.
Okay.
So just to add to that too, you asked about the number of inspectors.
Yes.
Prior to the accident, there were 34. 11 of them were aviation safety engineers, and 23 of them were aviation safety inspectors.
Okay. Those numbers, what do we know what they were like pre-2018? Were there more inspectors or less? Do we know?
We do not know.
I don't know. Okay. I see that in fiscal year 2023, there were 76 audits, I believe, is what I read in the report. And there was a comprehensive audit in June of 2023 of the Boeing's quality management system. Is that correct?
Yes.
And I think that's the every 24-month one, correct, that you were talking about?
That is correct.
Okay. And it's, I was looking at this, and it says the audit includes examining Boeing's QMS for compliance with all 15 elements required by law, including supplier control, manufacturing process control, inspection and testing, and control of quality records. Is that correct?
I can say that staff did not see evidence of all elements being covered during the interview process. In other words, they couldn't define for us when they were going to look at any one of those elements in a given year.
Okay. Do we know what the results of those audits were? Were there non-compliances?
I do not know.
Okay. I think I read, looking at through the docket, that there were 68 alleged non-compliances in that 2023 audit. And one of them was FAA identified training deficiencies as an area of concern, particularly with workers not knowing how to find the manufacturing documents needed to complete certain tasks. Did the FAA identify lack of on-the-job training as one of these deficiencies?
I do not believe the FAA narrowed it down to that specific source. I think it was considered as training as being more holistic.
Great, thank you. See, my time's up. Thanks.
Thank you, Member Chapman.
Thank you, Chair. Dr. Woods, I think this is a question for you, but certainly I'll welcome input from anyone who'd care to weigh in. The draft report we're considering today includes a recommendation which would call on Boeing to develop a process that, and I'm essentially quoting here, identify escapes that result from human error, assess those escapes using a system specifically designed to identify factors that contribute to such errors, and implement effective mitigation strategies. You might recall that after reviewing an earlier draft, I expressed some concern that such a process might simply be layered on the existing and relatively complicated procedures that are already in place. And those procedures, of course, ultimately proved inadequate to safeguard against the human errors that resulted in failure to properly reinstall the door plug on the accident aircraft. In response to my concerns, you helpfully explained that the process envisioned by this recommendation is seen as something of a bridge between the current state of affairs at Boeing and full implementation of Boeing's relatively immature safety management system. Would you please talk about the relationship as you see it between Boeing's existing quality management and safety management systems and how they would relate to the proposed new system to identify escapes that result from human error?
Absolutely. So first we need to define what a QMS is, a quality management system, and that is ensuring that the thing that you are producing meets its certification and design standards set by the regulator, and that it also meets essentially what the customer wants. A safety management system is the function under which the hazards in completing that QMS work are identified and risk mitigation process is in effect. What we see with Boeing is that the QMS has been around for a long time. That is well established and that is very robust. However, on the safety risk management and the safety management system side, where that hazard identification has, as you pointed out, it's still a very immature product. And while we were there, we found that even within the upper tiers of Boeing, it was still very siloed. They were their own individual categories. In order for it to be an effective system, they have to be bridged. That should be a symbiotic relationship with, again, quality, ensuring that the quality, the consistency, the certification standards are being met, and the safety management system is in effect with everybody down to the production level being able to identify the hazards that are going on from day to day while creating and meeting essentially design certification standards. As they continue on their implementation process, there has to be greater understanding throughout all the levels of Boeing, and at the time of the investigation, we just weren't seeing that. Therefore, staff has made recommendations in that area.
And do we feel confident that this new system that we're recommending, this sort of bridge system, that it won't detrimentally increase the level of procedural complexity?
No, not necessarily. I mean, the process in and of themselves are fairly straightforward and can be simplified. I think that right now there might be a lack of understanding in how to capture those processes and how to implement them and how to train and inform your people as to what they are. So for that, absolutely, there could be some growing pains that needs to be worked through, and that definitely helps with, for instance, Oversight to come in and do that course correction when it's needed. But the processes behind safety management systems are actually fairly simple, to the point where even a one-person operator Part 91 operation can have an SMS of 1. It's designed for that.
Thank you. Boeing's safety management system, I believe, correct me if I'm wrong, implementation began in 2021. Is that right?
They went operational in 2021.
Operational in 2021. And so at the time this aircraft was manufactured in September of 2023, the SMS at Boeing had been in operation about 2 years.
Correct.
And that's why we feel that it, at least, certainly at that point in time, and maybe still, a relatively immature safety management system, particularly for such a large organization.
Correct, and it's not just because only 2 years had lapsed. It's also because there was still they were still waiting on the guidance from the regulator as to what is this SMS supposed to look like, under what am I going to be, what are the standards I'm going to have to adhere to. That did not come into effect again until April of 2024, where they then had that guidance.
Great, thank you, Chair. Appreciate it.
Thank you. Member Inman.
I think, just to clarify, at certain ports in our report, it talks about a VSMS, voluntary. What's the difference in a VSMS and an SMS system?
An SMS system is regulatory. Oversight is provided by the FAA. For instance, in our air carrier Part 121, their SMSs are regulatory. They are mandated to have one, and the system is constantly checked. A voluntary SMS has all the same components, has a lot of the same structure as an SMS. However, the company or organization who has chosen to accept does not regulatorily have to do so.
But how did this come about for their voluntary safety management system that we were discussing? Was it from a 2015 settlement with the regulator?
So in 2015, there was a settlement that mandated that Boeing create an SMS system. However, again, there is no function for a regulatory SMS system. At that time, Boeing started their journey. Much later, in the AXA Act after 2020, then it was, the rule actually went to the FAA mandating the fact that they had to develop a mandatory SMS rule for Part 21 production and some others to fall under.
Okay, and I guess I'm going back to, in 2015, 10 years ago, this was an issue. Obviously enough to where there was a settlement agreement between the FAA and Boeing, but it was still in its infancy 8 years later?
Yes.
How long does it take to grow up?
Well, sometimes I think history forgets itself because, for instance, with commercial aviation, the Part 121, they went through these same growing pains in developing SMS. It wasn't something that was developed overnight. There were a lot of systems of trial and error to put what they felt they needed in place. The reason is because it didn't exist before that. So they had to make the determinations. They had to get the regulators' help. There was, again, a lot of trial and error to determine what this should look like. How do we do hazard identification? How do we build risk mitigation? How do we even do quality assurance and determine what it is we need to check after the fact? When it came time to look at the production side of things, there was a lot of things that they adopted from the Part 121 SMS structure in terms of, for instance, the 4 pillars, kind of the framework of what it should look like. But hazard identification is a very different environment to which those two, commercial aviation and production, work in. That had not been provided to them. So they also had to grow up systems of trials and errors to determine what does this look like? What should we be looking for? How do we conduct risk assessment? Also with very different people than you might find in a commercial aviation environment. Part of that is on the regulator. The regulator has to provide that structure, has to provide those rules as to what a company should adhere to, and that did not come along until 2024. So while you can work towards a product, I liken it to like building a house. You're trying to build a house and you don't get the blueprints until about 9 years later.
Is that not a little bit concerning? I mean, whenever we talk about trials and error in the production of aircraft that are being used to take people on public transport, I don't know that that's really a great excuse. I'm not blaming you for it, but it's obviously embedded of the system itself. But trials and error, and 9 years later, they still don't have the blueprint for how to manufacture an airplane. America, it invented aviation, and we're still figuring out how to try to make it safe.
I think there's a misperception in what I said, remember, and the trials and errors are on building the processes and understanding what the structure of your system should look like, not necessarily on the manufacturing side. The trial and error is in who do we have to have in place? Who are we supposed to train? At what level should they reach? Who should know about what? that sort of thing. That structure is where the systems of trials and errors took place, both in the air carrier side and in the production side.
Okay. I may go back to that in the next round that we go around, but I guess just for quickness, to the last question from this round, why are quality assurance inspectors not signing off on the totality of a project? It sounds like when this MED was taken out, should it have been looked at from a quality assurance perspective?
Should it have been? The answer is yes, but since no removal document was generated, there was no sign-off to drive any QA inspector to do the inspection, so it was the lack of documentation that caused there to be no quality assurance buy-off at the end of the day.
Great. Boeing 737 production line personnel who provided statements to the investigation included 24 door team personnel, the door manager who was on long-term medical leave, 2 quality assurance inspectors, 2 senior managers, a blanket installation manager, and others. Spirit personnel included 3 managers, 3 mechanics, and 1 quality assurance inspector. Those who also participated in interviews, a total of 17, included 5 door team members, a quality insurance inspector, 3 interior seat installers, a functional test team lead, a shipside operational inspection specialist. I could go on, but there were a number of statements and interviews, and I know we dug deep, but do we know who opened the door plug today?
Based on the written statements and interview, no one had knowledge on who opened or closed the MED plug because there was no removal paperwork.
So we don't know who opened the door and closed the door. And I know there's a lot of focus right now on people, and certainly there was after the accident itself, who did what when. But our aim was to figure out what, not the people, what was most important in the investigation.
What was important in the investigation is the process was not followed.
The process failures, that's exactly right. And that was certainly part of it. Now, what happened to the bolts? Do we ever know that were originally in the door plug?
We do not know where those bolts are.
Do we have a sense of what we think happened to them?
Those bolts may have been discarded.
Okay. And we state in the report, actually before I get to that, hierarchy of controls. This is something I'm very familiar with especially with manufacturing, and it's really something that you look at when you're talking about safety hazards and people, protecting them from hazards. But for hierarchy of controls and ranking of safeguards, measures to put in place, the most effective measure is certainly to eliminate a hazard. Second most effective is to substitute it. Third are engineering it out, engineering controls. We're talking about a modification to the door plug and some engineering design enhancements. Least effective is administrative controls, training, procedures, documentation. Why? Because it relies on humans. And finally, protective equipment. So my question to you is, we state in the report, I have 2 questions. Boeing's quality escape guidance did not adequately address controls for human error. What controls are in place today to prevent this from reoccurring?
So specific to this accident, as Mr. Crookshanks mentioned earlier, there have been design changes to the MED plug itself, as we can't do elimination, which, as you pointed out, is the highest level tier. So the next is engineering controls, and so that has been taken place. But we do have to look at the process and the people as well. And so going down that hierarchy of controls chain, the biggest process change that needs to happen here is, as I mentioned earlier, is you have a QMS and you have an SMS. They cannot be siloed. They cannot be independent things. They have to be a symbiotic relationship. They have to work in tandem to ensure that the highest standards of quality, certification, and safety are consistently met. And so that is the thing that Boeing has to be marching towards. And again, that is one of the things that we have found is important enough to our staff has proposed a recommendation in that area.
And I want to put an exclamation on that point. I thought that was very well said, Dr. Woods, because Mr. Cruikshanks is probably going to talk about the design enhancement, but that's still going through the certification process, right? So that design enhancement isn't in place. Those engineering controls are in place. So the question is, could this happen tomorrow if you do not have the right SMS and QMS in place?
There is always a potential.
Did you want to add? I saw you move.
Sure. Yes, ma'am. Thank you. In Mr. Cruikshank's presentations, not the least of which is the continuation of the AD, which was required as soon as the problem was discovered after the accident. So that's still a thing. It's still being used today. It is an administrative control, and as you've noted, that is generally less effective and less preferred over engineering controls, which we have recommendations to ask Boeing to keep pursuing those aspects as well. There's a few other things besides the AD. There's been some adjustments to the production line. There's been additional inspectors put, be careful with the word inspector. There are more eyeballs on the production of airplanes, and some of those eyeballs come from customers, and they also come from Boeing in other locations like Spirit. So there are a number of administrative controls in place today that we think reduce the likelihood of a similar accident happening again.
But it's critical that you have an SMS in place to ensure that you're evaluating potential risks, mitigating them, monitoring them for effectiveness, and if they are not ensuring they are effective, making appropriate changes to ensure that they are.
Absolutely.
Oh, that's great. Thank you. And I know we'll talk about some of those other things throughout the discussion. Member Graham.
Thank you. I'd like to go back to the voluntary SMS for just a minute. So it was approved by the FAA in 2020, implemented in 2021. So it had been up and running, although immature, for about 2 years. How did the FAA conduct oversight of the voluntary SMS?
There is no requirement for oversight or audits for a voluntary SMS.
No requirements. So inspectors from the FAA received no guidance on how to do any oversight. Is that correct?
Correct.
Very unfortunate. I guess that's going to change now, isn't it? Yeah. I'd like to move on to the hiring employees. In 2022, Boeing sought to increase hiring in an attempt to ramp up the 737 production levels to pre-2018 levels and make up for employees lost through the attrition between 2018 and 2022. The report simply states that during that time, Boeing hired people, many whom had no previous manufacturing experience. Do we know how many people were hired, like say from 2022 to 2023? Any idea?
I did request that information, and I have reviewed it. It was some time ago. I don't remember off the top of my head, but I do believe ballpark that they went from about 4,000 employees to about 7,800.
Okay, wow. Do we know if their hiring criteria changed during that time because of inexperience?
Staff did not ask that question. However, we do believe that the non-manufacturing experience prior to hiring was not considered at that time. So at that time, I would say no, it was highly unlikely they considered that in hiring. As for today's hiring practices, that's not information that we've received.
Okay. Before the accident flight, do we know how many hours of training were required for new Boeing door personnel? Do we know how many hours they needed to complete?
I do. So again, all employees, regardless of their job series, had to go through foundational training prior to the accident, about 168 hours worth of foundational training, and that would cover things like hazardous materials identification, the basic things that you need to be a technician on the production floor. Specific to the door crew themselves, the training was a matter of on the job, so there was no dedicated set of hours or prescription or grading system that was involved in the OJT. As essentially you were released to the floor and experience, you have your routine task, and experienced technician then teaches the less experienced technicians how to do the job.
And would that be for doing the writing removals also?
Correct.
So there was no structured training other than on-the-job training for recording removals?
Not prior to the accident, no.
Yikes. Okay.
Now, as we mentioned before, there had been some issues identified with the removal process. There had been an SRM that was currently work. So there had been training sessions that had occurred over the last 11 some odd years to where issues with the removal process have been identified, and there have been quality alerts, things of that sort. So there had been training opportunities to which people had to review the training and then sign off on it in some format. So there had been structures like that, but that is reactive to an issue having been identified.
So has that all been changed now?
It has. Removal training has been incorporated into foundational training now.
Okay, great. I see my time is about up. Thank you.
Great. Member Chapman.
Thank you, Chair. I believe this has been discussed already, and I apologize, but can you remind us where FAA is in the process of requiring safety management systems for all aircraft manufacturers?
I don't think I understand the question.
There's a rule now mandated by congressional act requiring safety management systems for all aircraft manufacturers. Where is FAA in that process now? When was the rule? Has the rule been made final?
The rule was final as of May of last year.
And when do manufacturers have to comply or be in compliance?
Within 36 months.
36 months, okay. Now, at the time our team of investigators interviewed FAA inspectors in connection with this investigation, the inspectors had not yet attended SMS training and were not yet aware of what the requirements for oversight of safety management systems would be. I think that's correct. Where does FAA stand now? Do we have any sense of that?
So several of the inspectors that we had talked to at the time that we were conducting the investigation have either been or have scheduled dates for attending the SMS course that they have set for them. They've also done a lot of extra hiring, though, for all ASIs. I do not have the information of the new hires. However, I think that the plan is generally those that were there first, they get through the program first. They do have a requirement, though, that upon hiring that they have to attend the training within 2 years.
But it does sound like FAA's got the training in place. They're starting to get folks into the pipeline, get them prepared for this so that they'll be ready to go when the time comes.
Correct.
So this is always a concern, of course. With enhanced oversight responsibilities, does FAA have the personnel and the resources necessary to conduct proper oversight of Boeing, specifically Boeing's safety management system? And I'm going to guess you'll have to offer a personal opinion on that, but if you have any sense, it would be helpful.
So the FAA has basically, after the accident, they've hired there was a 62% increase in the hiring of aviation safety inspectors. So it went from, before the accident, there were 34, and now after there's 55, they have more plans to hire additional people with regards to the oversight of the Boeing certificate.
And those are inspectors specifically for the purpose of inspecting at Boeing?
Correct.
If I could just ask, Dr. Woods, this may be you as well, I can't recall. Can you just talk a little bit about the concept of change management and what that entails?
Sure. change management is essentially, in any given organization or company, whenever you're going to introduce something new, there has to be, or there should be, an assessment on how that change is going to affect what you know right now. So that is how we're going to implement the change. First of all, what the change is, how we're going to implement the change, who it affects, who is going to reach, who do we need it to reach, how they should respond in reaction to the change. It's pretty systematic, but it's also pretty flexible in terms of whatever it is you're introducing, you want to consider the effect of that.
And we know that there have certainly been some changes in Boeing's workforce over the last several years, and there are a number of factors that have impacted the experience levels of Boeing employees. How would a change management assessment inform the company with respect to employees' potential additional training needs?
It would have identified the fact that the people that are currently on the production floor do not have the same level of experiences and backgrounds as they did 5 years prior. And what does that change mean to the overall outcome? Again, in a QMS-oriented, you want to meet your design and certification standards. So while the new people could maybe still meet the certification standards, what didn't occur was what unintentional hazards have been introduced as a result of there being less experienced manufacturing personnel.
Thank you. Thank you, Chair. I have additional questions in this area. I'll hold them for the next round.
Thank you, Member Inman.
So I'm going to go back to the actual removal of the door plug itself. And I think during his interview, one of the Boeing functional test technician leads recalled moving a maintenance stand which had the MED plug on it. This is in roughly pages 83 and 84 of the report. And that he took that and put it back in, leaving the gap between the frame.
That is correct.
Since we have so many different multiple personnel that are touching it, are there controls in place to stop an employee from performing a task that they're not trained on or are out of scope? Because this appeared to be out of scope by him taking it off the stand and putting it at least partially inside the frame.
Are there controls in place? In certain scenarios, there are controls in place, being that you have to have, let's say, an authorization to do something or a qualification to do something. And in those cases, CMIS, which is their automated computer system, would prevent them from signing off a task that they were not qualified to do. But there were no qualifications for doors and or door plugs on a 737, so there was nothing that could prevent a person from doing that.
So basically, if someone's not trained, they could still do it. It just wouldn't end up in the system.
Well, if it was a documented step, in other words, it was a sign-off step in an IP, and that sign-off had a qualification to it, then you must have that qualification in order to be able to sign that step off. So if you were not qualified, even if you tried, it would not let you. So someone who was qualified would have to be the person to sign it off. What you're talking about is not signing off something that doesn't exist, and I can't answer how that would happen.
That's okay. That's fair. But in this case, we identified, and I think earlier we talked about, there was only one person that knew how to take out a door plug. They had not received any training, but they'd just done it before, right?
They had done it multiple times before in the Renton factory. This particular gentleman had 25 years doing doors. He'd done about every job there was to do on a 737, and was very mechanically inclined.
So would he have been qualified to have done that in the process that you just elaborated on?
Again, there's no qualification. At the time of line number 8789 going through the factory, there was no qualification for 737 doors, and because of that, there's no limiting factor.
So if there's no qualification, does that mean anybody could have done? I'm trying to get to, you said earlier that someone had to be qualified to take something out or to put it back, and it would have been caught within their process. But it sounds like no one was qualified, or at least certified. So would the process, how did the process allow for these doors to be removed and put back in the past if they went through the normal system?
Again, this is, the removal of a plug was a non-routine task because it was an NCO. And because it is non-routine, it's unanticipated, there isn't a training schedule to do it because it's not something that happens by script. In other words, it's not designed to happen. It happens because there's an exception. In other words, there were 5 rivets common to the forward door plug frame that needed access, and because it needed access, that had to be opened. I will say the door crew is the right crew to be opening it. They're the most familiar with doors and door plugs. But again, there should be training to teach people how to do jobs they're expected to do.
Would you speculate that non-routine is probably the greatest place to inject risk into the production process?
I think I would agree with that comment.
That seems like that would have been a primary focus on even a QMS, SMS, doesn't matter. Non-routine would probably be where the greatest risk is, and yet this was not something that was identified prior to this investigation?
Not to my knowledge.
Okay. I've got more questions in the next round.
Great, thank you. The 6 key performance indicators that Boeing is using to monitor its production health are employee proficiency training, notice of escape work hours, supplier shortages, total rework hours, traveled work, and airplane ticketing performance. First, do we know, are they red or green on any of these? And I know it differs by day. Do we know? For the 737 line.
Give me a minute. I think we might have some information. Hold on, I got to look something up.
Okay, well then we'll come back to you on that. How do those key performance indicators, Dr. Woods, differ from what they were prior to this accident?
So the performance indicators themselves don't actually differ. They're just part of a larger body of indicators that they previously looked at. Prior to the accident occurring, there's probably somewhere upwards of 100 different indicators for different things that were constantly brought to people's attention. After the accident occurred, and in response to the FAA request to essentially build a plan for making sure this sort of thing doesn't happen again, they identified 6 indicators that Boeing, in conjunction with the FAA, felt was a holistic timestamp, if you will, of everything having to do with the humans. So with that, training, as you mentioned, was the first, to how they're performing on the production, how their suppliers performing, and then the ultimate goal, which is ticketing, which is getting that aircraft out to the customer. So that was what they essentially narrowed down their hundreds of KPIs to just those 6 to as a special interest item, if you will.
Yeah, and you brought this up at the hearing, and I thought it was an excellent question because they are essentially the same. There might be several more components. So what I'm wondering is, how does Boeing and FAA know that they're looking at the right data? What's changed? What's the process change in how they look at that data? How they talk to each other in reviewing that data?
So we asked similar questions to a lot of the executive levels, and one exec in particular, I think, had an outstanding answer, which I think is very valid, is that you don't necessarily know, but you have to start somewhere. And the first thing is again, that holistic approach. We're looking at the humans, we're looking at the production, we're looking at the end goal, which is, again, ticketing at the end. So with that, now what are we looking at what are our control limits? And that information is constantly being fed up. KPIs, this process is not meant to be stagnant. It's constantly evolving, it's constantly moving forward. And there may be some time down the road where they discover that, hey, maybe this is not the thing, or maybe something finally gets in control. That means that we just ignore it. Maybe now it's time to bring another indicator that would help further process even more and start looking at that one and going after it aggressively. So I think the takeaway here is that they had to start somewhere. This is a good approach as far as tapping all the different things that we want them to look at in terms of both quality and safety, and then also that it doesn't remain stagnant. They have to keep maturing the product. They have to keep maturing the SMS. And so then later on down the road, again, maybe there will be a different trigger altogether that they'll look at.
Yeah, so I think that's an important point, that it not remain stagnant, which is why I asked the question, because we state in the report at the time of the accident, airplane was in production at Boeing's Renton facility. Boeing required no task list, grading structure, or training documentation for the on-the-job training performed by Boeing 737 door team members. Boeing relied on the expertise of more experienced personnel who had also not received formal training. Is that right? Yeah, so we're talking about now they're getting removal training as part of the process. What I'm really concerned about is that they're so focused on door plugs and removals of parts or certain areas that there might be missing something else in the manufacturing process that they're not seeing right now. Hopefully that would get done in their QMS and SMS, and they're looking at the key performance indicators, but that is my concern, that they look broader. You're welcome to comment on that.
We are also concerned about that. NTSB staff is concerned about that, and therefore, one of the proposed recommendations in regards to training is not just delimited to door crew, for instance. It's something that we would like them to take a look at for all the job series and creating a structured program that is identifiable, gradable, scalable, archivable, so that some of those aspects, as you said, what else might be out there in the production, they can also be addressed through that format, not just through the SMS.
Excellent, thank you. And Doug, I can come back to you on the next round as well if you don't have that. No problem. Member Graham.
Thank you, Chair. I want to go back to the beginning when the accident fuselage showed up at Renton. What's one of the first things that was done with that fuselage? What did Boeing do with that?
One of the first things that's done is they do basically a receiving inspection coming off of the train to look for damage. But prior to the okay to install blankets, or while accomplishing the okay to install blankets, they are looking for workmanship defects, anything damaged, torn, open holes, things that don't look right. And this was actually the point in the inspection where they found the 5 discrepant rivets common to the forward frame.
Okay, so they didn't find it on their initial inspection. The MED plug was in. I assume they maybe looked at the bolts, maybe not, but they didn't look at the rivets in the frame at that point. Is that correct, or
Well,
nobody noticed it?
The MED plug is actually installed at Spirit.
Correct.
Prior departure, and
so
it was not picked up. There were no discrepancies noted departing Spirit, and it was picked up during a okay to install blankets IP during flow day 1, basically.
Flow day 1. So somewhere between, flow day 1. And that rivet work, how far did that travel down the line? To what flow day did it finally get repaired?
It was corrected on the 19th. Well, they drilled them out on the 18th, and they were reinstalled on the 19th of September, which was flow day 10.
Flow day 10 or flow day 9?
Flow day 10.
Flow day 10. It went down the whole line.
Correct.
Is it different now? Would that be different now with what Boeing has implemented?
Boeing has put in place a ready-to-move process that is to evaluate the risk of sending something forward that has open work still left on it. So in other words, they have to have a plan to correct that open work. I think they thought they had a plan when 87, 89 was going through, but obviously that didn't work. So how can I answer your, what further question do you have?
Yeah, I was out there at Boeing, I looked, and they have a process in place of whether they're going to hold up the aircraft move down the flow or not for certain things, and there has to be a good reason why they're going to move it, and then a actual stopping point where that fuselage will not move any farther, that aircraft will not move any farther unless these certain requirements are completed. So they have put processes in place in this case.
Correct.
So I have a couple more, but I'll come back at the next round.
Okay. Member Chapman.
Thank you, Chair. I want to be sure I understand what should have happened after it was determined that rivet rework in proximity of the door plug was required. And if I have this wrong, please correct me, because I really do want to make sure I understand the process. So when the non-conformance record and the non-conformance order for the damaged rivets were created, Boeing then should have assigned a quality assurance inspector to determine whether the rework required a removal of the door plug. Is that correct?
When the NCR and NCO were generated for the 5 discrepant rivets, no, that they would not have had, what was created was a NCO that gave instructions on correcting these rivets, and what the Boeing spec was that you would use to correct the rivets. It didn't cover anything to do with access. When you generate a removal, then you would have instructions for what to do to open the plug, what you would do to rework the area. In other words, point back to the other document, and then what was required to close the plug, and a final inspection from Boeing Quality Assurance.
And how would the removal have been documented, or how should it have been documented?
Removals are generated in CMIS. There's basically a pick list that you can go through and pick the items that you want to cover. If you have if they have electrical concerns or hydraulic concerns, there were about it seemed like about 20 different options to pick things. But okay to install was always one of them. Okay to remove was one of them, although the okay to remove was generated by a mechanic and the okay to install was generated by an inspector.
Okay. At some point, then, a removal record should have been attached to the non-conformance order. Is that correct?
A removal record should have been attached to the IP that documented the 5 discrepant rivets.
Okay.
I don't believe you would attach a non-conformance order to a non-conformance order.
Okay. I think fundamentally what I want to get at here is, what has Boeing done to update its processes since all of this occurred to ensure that if a door plug is opened or removed for any reason during manufacturing, that the appropriate removal paperwork is generated and retained?
Boeing's done quite a bit, actually. One of the things they do is they placard the plug from the outside, saying, if you're going to touch this, you need to know what you're doing. You need to get people involved.
So to add to that too, is they've had numerous trainings with regards to removals, not just from the door team, but the rest of the manufacturing personnel.
Okay. All right. Thank you. A question about the design changes that that are being made to the door plug to ensure that if removal is required, that all the bolts are reinstalled and the door plug is secured. That is currently in the certification process at FAA, is that right?
It's in certification planning at Boeing and Spirit, and
Okay.
the FAA has been notified.
Okay.
I'm not sure where exactly in the process
Okay.
it is at FAA.
The plan here then is that at the appropriate time, there will be an airworthiness directive requiring installation of the redesigned door plug on all new aircraft going forward. And then there will also be an airworthiness directive, as I understand it, requiring retrofitting on aircraft that are already in the fleet. Is that right?
There will be manufacturing instructions to install it in the factory.
Okay.
And then we are asking for the FAA to issue an AD against the existing airplanes in the fleet.
And do we have any sense whether FAA is open to that?
We believe they are in our discussions.
I know it's early.
Yeah.
Okay, thank you. Thank you, Chair.
Member Inman.
Going back a little bit about the FAA's oversight, and I'm going back to some of the interview transcripts, identified that they had inspectors present in Charleston, Renton, and Everett, and the managers met weekly to discuss administrative activities. However, there are no inspectors present at Salt Lake, Portland, Auburn, Frederickson, and Helena. Is that your understanding?
It is under our understanding that they had inspectors at Renton. We did not have discussions with the FAA about the other sites that they had.
Okay, this came out of the, I think, the principal inspector's interview transcripts, but it was a little concerning to see that they did not have them at so many different locations. It's because they only receive a few audits per year compared to, say, Renton, Everett, and Charleston. I'm going to go actually to Brian Knopp, who testified during our hearing, and he mentioned that he resides in Lakewood, California. He's the FAA's manager of System Operation and Oversight branch that handles Boeing, GE, Pratt & Whitney for their production on ODA and SMS. Do you all recall his testimony?
Yes.
I'm curious because we're now under, the president's had this new initiative about return to work and return to locations and remote work. And I know it's affected every agency and we've been adapting to it as well. Is there risk by having the head of the ODA and SMS from FAA residing in a city to which there's no FAA office?
As you mentioned, that oversight group is over top of Boeing, Pratt & Whitney, GE. So you're talking about at least 4 states that someone would have to be in simultaneously in order to be the one person in charge of overseeing all of that. If that was a concern and or interest, then the FAA would have to figure out how to divvy up duties such that you could have a manager in location with near proximity to each one of those facilities.
Okay, but there's no office in Lakewood, California.
Understood. Also, he is no longer the 580 manager.
He's been moved out?
I don't know the circumstances. I just know he is no longer the 580 manager.
And at the time that he was testifying before us, he had just been moved into that position, I think 3 or 4 months before?
I think it was 10 total. 10 months?
10 months? And so we're going through this, I guess, merry-go-round of people in charge of ODA and SMS. How do they get consistency if the FAA continues to churn through individuals in reorganizations and movement?
I can't answer your question.
Okay, I'll actually point to someone who does help, I think, answer the question a little bit, and that's the Inspector General for the DOT, who put out a report, I think in October of 2024, talking about weaknesses in FAA's oversight process and systems limit its ability to identify and resolve Boeing production issues, and specifically talking about they cannot track milestones, determine potential repetitive non-compliances have occurred. And I know I met with them and their head of aviation safety. They were talking about, even though we credited them with 62% increase, I believe you said, and the Inspector General still believes they don't have enough boots on the ground. Are there enough of people inspecting in a proper oversight role of manufacturing in the United States?
The FAA continues to hire people. Whether 62 is enough, that's between the FAA and Boeing to determine.
So we don't have an opinion if we said that there was only 40 before and that was fairly low, 62% increase to 55, I think 58. Is that better? I mean, obviously it's a higher number, but does that get us to the point we need? And I'll go to it, I guess, in the next round, but are they putting the right people in the right place?
Yeah, we don't have the answer to that. Whether I'm assuming that they're hiring the right people to do the job that they need to do.
Did you look beyond Renton on this? We were focused on Renton. Did you look at inspection numbers broadly at FAA and inspector levels?
We did not.
Right, okay. So there's been a lot of discussion about the impacts of COVID on hiring. Boeing, though, and I just want to highlight this, the safety deficiencies that we identified as part of this investigation, I want to be very clear, actually stem back much farther. We looked at compliance audits going back to 2013 with issues on the BPI, numerous changes with those instructions for parts removals, which were very confusing, 50 pages, people were confused, it was constantly changing 11 times. But those existed at least since the initial ramp up in production of the 737 MAX. And I just want to emphasize that change management is important. It is a critical process. We do it all the time. I can tell you, Dana, Darlene, Brian, I routinely every day are looking at change management for every process we're changing. And the same was emphasized in testimony when I talked about some of the changes occurring at DCA Tower after the January 29th event. You have to do change management to determine what effects or unintentional change effects come about from a decision that you made. What intentional, unintentional things were created to evaluate risk. So I just want to emphasize that. SMS, Dr. Woods, I think you've all done a very excellent job. I know it's a long morning. Is SMS static, or is it something that needs to be continually developed, improved upon?
No, it's got to be continuous because the circumstances are always going to be changing. Just like we talked about, there is now, they're talking about changing the design of the plug to ensure that it's safer. Things will change. Therefore, your SMS has to be constant to continuously evaluate what hazard might exist as a result of those changes, and then develop risk mitigations to prevent essentially an accident or an incident from occurring.
And can Boeing really implement that on their own? On their own with no oversight, is that the most effective?
No, I mean, for everything that we do, there has to be some sort of third-party entity coming in and taking a look into ensuring that everything is meeting standards. In this case, the regulator is the one who developed the standards, who said what the standards are going to be. Therefore, they have to provide oversight to ensuring that Boeing is meeting the standards.
And so, I mean, that's the big difference between the voluntary SMS and the mandatory SMS under the law, which is they really didn't have a set of standards. They submitted an SMS that FAA accepted, didn't really meet a set of requirements in a regulation that was standard, and then there was no enforcement. So one question I have is, and this was pretty evident in our interviews of FAA after this accident, is their inspectors seem to be unaware of how to do safety management, how to enforce safety management, and how do they address safety culture. And I'm wondering what has occurred since the accident there, because yes, Boeing has created a lot of procedures and a program around SMS, but it also takes a regulator who's very familiar with how to enforce, how to conduct a proper oversight.
Correct, it does. And so part of this, as we mentioned, I believe a while back about at that time, the FAA or ASIs, they hadn't had training. Since then, quite a few that we talked to had either had training or they have been scheduled. Their training is upcoming. They also mandated that within 2 years of a new ASI hire that they have to go to the training. So I also mentioned earlier that this is the part of that growing pain that I was talking about. This didn't exist in a production environment before, so everybody's going to have to learn and come on board and understand what their role is that they have to play, and the FAA is a significant part of that.
And what is FAA's role on Spirit? Assuming Spirit is separate, obviously there's some discussions about them coming into Boeing, but what is the role there? I know that Spirit is also implementing an SMS.
The new rule does not extend to suppliers.
Okay. Thank you very much. Member Graham.
Thank you, Chair. As part of the post-accident investigation, Boeing was required to provide a detailed update to the FAA on actions they had taken in the wake of the accident. These included strengthening voluntary safety management systems, simplifying their internal processes and procedures, clarifying work instructions, enhancing supplier oversight, increasing internal audits, improving installation plans, and enhancing employee training. To date, and going throughout the investigation, how many of these items has Boeing addressed?
You kind of ran the gambit there, so I'll start with
Yes.
training. They had already had changes to their training program, essentially before we came to this report, like as we were writing our report, and that is that they have increased their foundational training for all technicians, upwards of about 57, 60 hours, and it includes administrative tasks such as understanding BPIs, specifically the removal of BPI. That is now incorporated in the foundational training. And while we only, in the confines of this investigation, asked for how training had been adjusted for the door crew, we have asked as a proposed recommendation that that happen for all job series, and that is that OJT has to be essentially prescriptive. It has to be mandated what it is that you need. What does it look like to be a fully proficient and qualified job series member? It needs to be graded. So how does the individual know that they've achieved the goals? What are the goals? How do they know they've achieved the goals? And then it has to be documented so that you have archival data later. One of the things that staff found concerning as we went is we had to ask the individuals if they had done work on an MED plug before, whereas there should be some sort of database that you could go to and it should be able to spit out these are the exact number of technicians that you have that are proficient on this task and the ones that you should seek out to do the task to mitigate risk. Moving on to, I guess, the other.
How about SMS?
Well, for the SMS, that is still ongoing and it's still being encouraged. Again, new rule came out. Now they have a little bit more a definitive structure as to what exactly it should look like. The things that they had put in place, they remain. Again, they patterned a lot of those off of what the commercial Part 121 SMS looks like, but now there will be some adjustments. Also, there is now a holistic effort to make sure that everyone understands all the way down to the technician level what the role is. That's actually another part that's been added to the foundational training is what is SMS? What is your role in SMS? How do you identify hazards? And there is strides to make that a part of recurrent training as well.
Yeah, and I know I talked about a lot of other ones. I don't need individual updates on each, but does it appear that Boeing is taking the corrective actions necessary to improve their processes and procedures?
I would agree with that statement. In addition to that, they have formalized 737 door team training now too. So prior to the accident, there was no formal training for door crew people.
I saw that 2 weeks ago out there, and it looks like they're defined procedures and processes in place for just about everything they do and jobs, or what the requirements are, what the training's required for them. So, and this, I'm asking for an opinion here. Does it appear that they're trying to take making corrective actions for their safety culture? I know we didn't do a safety culture survey, but does it appear they're trying to make strides in improving their safety culture?
So after the accident occurred, I know that Boeing, on their own, without additional guidance from the NTSB or as a result of this investigation, has undertaken internal surveys and internal audits trying to essentially assess their own safety culture. And in doing that, they have gained information that they do in turn to go back to use to help inform their SMS process going forward. So it would appear that they do recognize, but to be clear, in our conversations with the executive levels, there was an understanding there of what SMS is, what SMS principles are, why it's important. The problem was that that didn't permeate down, and so some of the things that both NTSB NTSB staff and some other external audits have identified is there is this huge gap in knowledge, this gap in understanding between the executive level who set the policy and may understand, and the technician level who is actually going to be the most beneficial in identifying the hazards. They're the ones who touch it every day in and day out. So if they don't have awareness, then it doesn't matter how informed your executive level is, your SMS is still not going to work.
Absolutely, I agree. And it doesn't appear that it was there at the time, but I think they are making strides to make sure it gets down to the floor.
I would agree.
Thank you.
Member Chapman.
No further questions in this area for me. Thank you, Chair.
Member Inman.
So I'm going to go back to, I guess, 10 years ago. It's actually 2013. A KO, it appears, adopted SMS as a suggestion. It was ratified in 2007, or proposed in 2007, ratified in 2013. And we're 12 years later, and we're still trying to figure out how to get SMS integrated?
Yes.
Does that worry you?
I think that the things that we've seen and the things we've already talked about and discussed are very positive. Boeing is moving forward. Even within building a process, it's a process to build a process. And some of the things that we've seen, so long as they adhere to what they say they're going to do, and in addition to a lot of the recommendations that staff has made, I'm very encouraged that that they will build that structure between, again, having a QMS that has been around for a very long time and is very robust, and an SMS that needs to be just as robust and as powerful as its QMS.
Well, it bothers me. And the only reason I bring it up is I remember 6 years ago, we're talking about MCAS. That was the shiny object of the day. You know, several years ago, we had a lot of hearings here about near misses. That was the, I don't want to say the shiny object, but that was what we were looking at then. You know, we continue to go down through these processes. Last year, we were talking about manufacturing and supply chain integrity. And now this year, we're talking about air traffic control and helicopter operations. Every year, we seem to have to move on to something else. And I said it during the hearing, it was whack-a-mole then. Just what do you keep trying to push back down? How do we get to a place where we feel comfortable the entire system's working for aviation safety for everyone?
This might be an unpopular opinion, but I personally do not feel that you can ever 100% get to zero. I feel that that is, a lot of people will like it to be that in a perfect world, but that's not what we have here. There is an inherent risk to what we do. There's an inherent risk to aviation. So therefore, the focus and the goal is to get to what is acceptable, how do we identify the hazards, and then how do we contain that hazard by loading on risk mitigations and controls. And by that mean, we decrease the likelihood that we will encounter the hazard, or if we should have to encounter a hazard, we want to ensure that that encounter does not have a very severe outcome. Minimal damage is done with the effect of coming into contact with the hazard. That's the goal. We're no longer flying bi-wing wooden planes. Aircraft have gotten inherently more complicated. People have gotten inherently more complicated. Technology has gotten inherently more complicated. So there will always be something on the horizon that we have to continuously look at and adapt to. So what we do is we learn from those things and we build these processes and we build these systems. And moreover, we have to have a willingness to adapt and to identify and go, you know what, that's not working properly. We need to identify that. We need to get on it and not just accept things as the status quo. If anything, I can say that might have harmed even Boeing in the past, is they had a very experienced, very seasoned workforce that they relied upon. In a structure to maintain quality, you need experience, training, tools/guidance, and oversight. A lot of their experience got up and walked out the door. So that just left training, tools and guidance, and oversight. So if one of those other three things is not as efficient as it should be, then yes, you're absolutely going to have a problem.
I don't think your opinion is going to be unpopular. we can do better. We can try to do better. I mean, as I understand it, over 500 million people flew on Boeing airplanes in 2023 alone. We want every one of them to get there, but we have the ability to move 530 million people, not including the rest of our aviation sector. We can stop all commerce. We can stop these near misses. We let one airplane operate on the tarmac at a time. Want to get the fatalities down for highway crashes from 40,000? Sure, set the national speed limit at 5 miles an hour. I mean, the safest plane is the one that never takes off. But we are allowing for innovation, so I appreciate your commentary, and I don't believe it's that unpopular as you may think. That's all I have for this one right now.
Great, thank you. Are you aware whether FAA conducts their own SMS on themselves and on the aviation sector?
So I do believe a part of that AXA Act in 2020 was also for the FAA to establish its own internal SMS and to establish its own safety culture. Being that, if we're talking specifically about the production environment, as we established, it wasn't a regulatory requirement. There wasn't anything there in place. There was an Office of SMS that helped set up voluntary SMS programs and approve them, but after that, there was no oversight, no auditing process. So I cannot necessarily answer the part of bridging that gap yet. It will remain to be seen how FAA takes that on for production. They've been doing it for a long time in the commercial side. But internally, yes, the FAA also has to conduct its own SMS plan and identify its own hazards. For instance, not having ASIs who are trained to provide oversight for SMS, that would be a hazard that they would then have to also develop risk mitigations for. What is our plan going forward to get our ASIs trained? That sort of thing.
I would imagine if they do have one that they should probably relook at it because they might not play whack-a-mole all the time. Okay, what is just culture and why is commitment to fostering a positive safety culture and promoting a just culture important?
So within any organization, agency, company, a just culture is where the people, the employees are comfortable and there is trust there that they can acknowledge when a hazard exists and without fear of reprisal or feel of being labeled, for instance, a troublemaker for identifying that, hey, something isn't going wrong. It's also a culture to where if a person makes a mistake, they can own up and say, hey, I think I messed this up, I made this mistake, and there's an understanding that like the hammer just won't drop on them. It's not to say that all mistakes we just look the other way. It's to say that each individual error or mistake is looked at in context and determined where the breakdowns and deficiencies were, recognizing that people are going to make mistakes. It's processes that break down to where people, that escape gets through. And so that whatever it needs to be to contain and shore back up that process is adhered to. For instance, it could be retraining, it could be identifying that a tool is insufficient, but it's not just that, hey, somebody did something wrong, let's punish the individual. It's bigger than that.
And I do think it was the right call that we not do the safety culture survey, given everything that was going on with the work stoppage. And even coming back from a work stoppage, you're in a different place than you were in September of 2023. One question about that, I know that Boeing has been doing its own safety culture surveys. I would just, without asking a question on that, encourage them to continue on with that in their review and implementation of measures to improve safety culture within their organization. We do have a recommendation on this, and one thing I'll ask is Section 103 of the Aircraft Certification Safety and Accountability Act of 2020 directed the FAA to convene an expert panel to review and make findings and recommendations on the safety management processes and their effectiveness for each holder of an ODA for the design and production of transport airplanes. The expert panel's membership composition was designated by law and included a combination of NASA, FAA, aviation labor, aviation industry, and independent experts. While most aspects of ODA are focused on design and certification, the panel is focused on safety culture. SMS and ODA applies across Boeing. Do you know what the expert panel found, and what are the benefits of a neutral third party, such as a independent panel like this, how can they help improve safety and safety culture for Boeing?
So I'm going to answer your question kind of in reverse. So the benefit of a third party is that it takes out the bias. Sometimes it's very hard for us to assess ourselves. And so you need that third party, independent, fresh eyes, if you will, to be able to come in and identify the issues that might be within the organization. Now, as to what that team found, we've actually talked about quite a few of them because some of those things they found have persisted and some of the things that NTSB staff has also found. The first is that there's a very big disconnect between the executive level of Boeing, the higher level management, what they know and what they appreciate, and what the actual technicians on the floor understand and appreciate. That gap absolutely has to be bridged and filled in order for their SMS to work. Another thing that they identified was the fact that, and I think this, again, kind of harkens back to the growing pains, is that the attempts to install SMS within the system are very complex. It's not to the level to where just an average person is going to understand it and be able to go to a training and be able to understand what their role is and do the thing that they're supposed to do. So they need to shore up that part. There wasn't a lot of consideration for, interestingly enough, human factors. And that is where I've said before that, like, for instance, in the production rate change assessments that they would do, it was very focused on the quality side. You know, do I have enough people? Are there enough tools in place? And not quite as focused on some of those intangibles, like, are my people actually trained to do this job? That would be a human factors issues. Having enough people is great, but are the people qualified, proficient to do the job? That is another aspect. That's a part that needs to be developed in that SMS side, and then again, bridged to the QMS side so those things meet. All of those things are what that independent panel found, and all of those things are largely what we found to persist when we did our investigation.
Yeah, and it would be interesting to see what's changed since then. Member Graham, Member Chapman, Member Inman.
Yeah, so I want to go back into a little bit of the FAA's oversight again. You know, can someone document specifically the flaws with their compliance and enforcement activities that may have resulted in this?
So based on staff's investigation, there were a lot of issues with regards to the removals and what they found during the removals. Again, they only had 5 years with regards to keeping all those records. The compliance are basically regulatory violations that they were supposed to keep. So based off of that, they were unable, the work program asked them to look at the previous issues with regards to any systemic issues with regards to the removals, and that wasn't happening, and that was the case that we found, that they weren't looking at or auditing the things that they needed to audit at that time.
But it goes back, I mean, I think we actually talk about it in the report, that in 10 years previously, that the Boeing's BPIs had a history of compliance issues. I mean, despite there being that going on, why did it continue for 10 years?
It's because that they don't have the system wasn't in place for them to be able to look at all that information back then, to be able to drive the audits at that time.
So they were ineffective in their oversight.
Correct.
Do you think they're effective in their oversight now?
There potentially could be holes in their oversight, sure.
It's a very good answer. Potentially could be holes. If the FAA had an opportunity to make a specific change this year in one area, what would that be in order to gain less holes in their oversight?
Their risk-based assessment tool needs to be a lot better.
So you think that there's a fault in the risk-based assessment? I think that's what the IG found as well, correct?
Correct.
So it's us and the IG are both recommending this.
Correct.
Okay. Let's talk for a moment about the shipside action tracker, the SAT. FAA's frontline managers stated in their interviews that parts removal out of sequence are chronic within Boeing's production system. So how does the SAT actually play within the assembly of an aircraft? How does the SAT pick up on chronic issues to be able to identify them?
The SAT does not. The SAT is think of it as a trouble ticket system. So when you contact IT and say, my computer doesn't work, they create a ticket. It's specific, that log is specific to what your problem is. That's the same thing a SAT does. So a SAT, in this case, there's 5 discrepant rivets that we need to get resolved because it's holding up production or the completion of production. So it was there to track progress and status, and it was updated at the end of every shift. So it went along from flow day 1 through flow day 6, I believe, when the initial attempt to sign off the rivets occurred, and when Boeing quality refused to buy off the rivets, and when they said they had signed off that they had been replaced and they actually had been painted over because he thought he addressed them satisfactorily, that the failure of that buyback is exactly what that process should do. It rejected work that was not satisfactory to the QA inspector. So that one worked, but then it continued on after that from flow day 6 all the way to flow day 10, when it's getting ready to roll out the door and people are saying, this is still open, we need help, we need help, we need to get this thing done. So that's what the SAT record showed.
But it sounds to me like SAT is a way to get airplanes out the door so they can be sold.
No, I think SAT is a way to track a single problem from beginning to end so that you have a conclusion. It's not a documentation of the system. In other words, it's not a manufacturing record, but it is a document that tracks what occurred shift to shift.
Okay. Mike had mentioned the move ready process. I also saw that when I was there, where, you get to, at each flow day, they have a banner where they go through certain questions of, did this get completed, did this get completed, did this get completed, and then at the end of the day, the managers and the rank and file get together, the mechanics, and talk about were all those procedures, was everything done? They won't go through those questions, and then they determine, is this ready to go to the next flow day? They had mentioned that this would be caught in flow day 3. We know this went through to flow day 10. Do you believe that, or do you have some concerns it might go beyond that, or it might not catch it? I just want to.
We did not study the move ready process because that was implemented actually after the investigation. What I will say is, I think it's a good start, but once again, failure to document something is very hard to detect. Mm-hmm. So if you don't have it documented that it wasn't done, I don't know that process catches it.
Right, which is why you need a design change. So, Mr. Cruikshanks, you're up. Boeing intends to pursue a design enhancement for the MED plug door. Can you talk about how that came about? What will the design enhancement do, and where is it in the certification process?
So the design enhancement adds 2 pieces of structure to the plug that will prevent it from moving if they're installed correctly, or if they're in position. And further, you won't be able to put the sidewall panels onto the airplane without having those installed. And additionally, they're going to put lanyards on the bolts so that they'll hang there and be visible to a mechanic that had taken the bolts out. As far as where it is in the process, the engineering's been done. Spirit and Boeing are looking at the planning, the production planning process and submitting it to the FAA for approval before it will go into production.
Will that design change only apply to new airplanes or retrofit as well?
Boeing has told us they intend to issue a service bulletin to retrofit all existing airplanes, and we have a recommendation for them to implement that.
Great. And is there, and I shudder when I ask this question, is there an estimate for how long the certification process will take? Will I be collecting Social Security?
The information we have says that it should be start to be installed in the factory in 2026. So
it's like a rush certification process. Okay, well, maybe they're making, maybe they've done an SMS or some improvement process for certification that does not take 7 to 10 years. Great. So in the meantime, they have these other procedures in place, which is a good start, right? FAA, I do want to go back to them on inspections. What type of inspections and specifically what I'm asking is not necessarily quality system audit, principal inspector audit, supplier control audit. Most people don't even know what that means. I'm not sure I do. I'm kidding. I do. But are these before this accident? Because I haven't really gotten a good answer, not from us, from FAA. Were inspections announced or unannounced? Or both?
The answer we got during our interviews, they were always announced because they set up with their colleagues at Boeing, time, place, location to meet, and they almost always shared what they were going to look at and where they wanted to look at it. Since then, during the hearing, they said that they will share, they will notify them they want to do an audit, but they're not going to share always what they want to look at or where they want to look at it, so you can't prepare for the test.
Seems like an excellent idea. I mean, I do understand the need to have some announced audits, but unannounced can also give you a better sense of what's really going on a day-to-day basis. Okay, Member Graham. Member Chapman. Member Inman.
I'm going to actually take a moment, I guess, to put a positive spin on something. And I think we often are caught up in tragedies. I know from the DCA midair, what happened in India, we talk about these tragedies, and rarely does everyone ever focus on tragedies that don't happen. So could someone from the team tell me, was this plane certified for ETOPS?
It was.
And that ETOPS is an extended range, flying over water. Does that sound correct?
Correct.
Only reason I bring that up is that I think in this case we should applaud someone who actually adopted SMS before SMS was mandated, and that was Alaska Airlines. Was this plane able to fly under the FAA regulations over water for extended distance?
At the time of the accident, it was not, and I'd like Mr. Hooray
Well,
to...
wait a second. My question was, under the FAA regulations, were they allowed to fly this?
At the time of the accident, the aircraft was taken off of ETOPS because they were flying with a deferred item on MEL.
The question is, under the ETOPS program, were they allowed to fly under the FAA reg?
Not at the time of the accident, because there was an MEL. They had a deferred item for an MEL, which required them to take the aircraft off of ETOPS for that flight. It was a separate item from, from anything that we've been talking about so far. It was they had a fuel pump that was on MEL.
I want you to go back and correct it, because I believe, if I'm correct, and maybe I'm wrong, I apologize, you're the experts, their voluntary SMS program had caught this as being a recurrent item, and so through their voluntary SMS program, they pulled it from ETOPS, where they could have still legally flown it under their certification. Does that sound correct?
I'm sorry, can you repeat that?
Under the Alaska Airlines SMS program, they had voluntarily taken this plane off because they saw a recurrent issue. But under the FAA certification for ETOPS, they could have flown.
That is correct. So there were two separate ETOPS going, there was two separate restrictions for ETOPS going on at the same time. One, the FAA would not allow them to fly. One, the FAA would have allowed them to fly, but the airline had taken it upon themselves to do that before they would let it fly again. So in other words, if they had corrected the issue with the fuel pump that was on MEL, they still would have voluntarily been restricted from flying.
I'm just trying to compliment. A voluntary SMS system that goes above a regulatory authority is a good one. Is that correct?
Yeah, agreed.
Okay. All we had to do was get to yes on that. Sorry.
If I can interject, though,
Yeah.
Alaska Airlines program is a regulatory SMS. It's not a voluntary SMS.
I completely understand, but they actually adopted the SMS before it was regulated. It's more mature, if that's a good way of putting it.
It is.
Okay.
But all Part 121 operators had to adopt full regulatory SMS, I think, in 2012? Question mark.
It's okay. I just want to call out, there's operators out there that are flying, and I know others that are trying to go beyond the mandated level of safety, and for that, we should applaud those, because this could have been a much bigger incident had we seen a door plug over a water or extended range. Luckily, it was in Portland and was able to return very quickly. The circumstances we talk about would have been very much different had not the system worked in certain places. Can we get yes to that from anybody?
I concur.
Thank you. I guess I want to also one quick thing about this removal, and has to do with rig documents. Whenever you're talking about rig documents, this is how certain members of the team learned how to take the door plug out. I guess is that correct?
A rig document is an IP that checks the door plug for dimensional flushness. So no, it's not a teaching tool. It's a instruction to measure the door plug to make sure it's got proper gaps centered and it is not out in the wind stream. It's underfared for fuel efficiency.
But it's the team lead, as I understood it, learned how to do this because he had not been trained from reading the rig documents.
Rig documents. Oh, yes, I'm sorry. He referred to, the gentleman interviewed referred to the drawings which were used to rig the plug at Spirit. So as I mentioned earlier, he had very good mechanical aptitude, and he took a manufacturing drawing that had rig tolerances to it and figured out how to take it out and put it back in. He taught himself.
Out of time.
Okay. I want to go back to FAA real quick. Retention of records, because we have a recommendation on this, or that includes this. Retention of records documenting noncompliance, as well as having a system that tracks noncompliances, can help certainly proactively identify safety risks. FAA only maintained records at the time of this accident for a period of 5 years. Why is it important for historical compliance enforcement and audit records older than 5 years to be retained and access granted to FAA managers and inspectors? Why is it important to have more than 5 years?
So that inspectors can use that information and use it systematically for next fiscal year's plan for that particular for Boeing.
Yeah, 5 years is a pretty short time period. Do we have a recommendation on how long they should keep those records?
We did not prescribe how long they should keep those records.
Okay. And what is risk-based resource targeting?
It's a tool that the FAA uses to assign risk. Unfortunately, it's not nearly as fancy as it sounds. Once again, Boeing will always be a one high and what it should be doing is looking at where Boeing's having problems and cause more frequent inspections to occur or audits to occur in those areas where they're actually having problems, and reduce the number of audits in areas where they're not having problems, to be a true risk-based tool.
Well, how do they use it? And just in 23, FAA did determine that Boeing's Renton, Everett, and Charleston production sites were each level 1 high risk. So how do they use that targeting for risk-based analysis?
Again, I believe it's a misnomer. By definition, any manufacturer that produces at least 100 aircraft is a 1 high. So there's no way of getting to an answer not 1 high.
Got it. Okay. And my final question for this round, for right now, we're going to talk about recommendations at the end here. We do have several other rounds of other questions, but are the recommendations in the report applicable to only Boeing's 737 production line, Doug, Mr. Brazy?
No, ma'am, they are not. Many of them are platform agnostic, I guess. They apply to the whole company and not just the 737 line in Renton.
So 767, 777, 787, all the production lines.
Correct.
Okay, thank you. Member Graham. Member Chapman. Member Inman.
I've got a few I'll just throw into the catch-all in light of hopefully getting a lunch break in a little bit.
Okay, we're going to get a lunch break right now. That was a big hint. I like it. All right, we're going to take an hour. Is that all right? For lunch, we will reconvene at 2 o'clock. Thank you so much, and thank you to the staff for the work so far. All right, we're going to get started again with round three. Round three is going to focus on operations, cabin safety, and related safety actions and needs. We're going to start with Member Graham.
Thank you, Chair. I'd like to talk about the oxygen mask in the cockpit, like we talked about at the break. So would you mind talking a little bit about how the oxygen mask and the speaker system works with headsets and everything like that, so everybody understands that?
Sure. In the 737-9, when the oxygen mask is taken out of the stowage box, the mask microphone is automatically enabled, but the overhead speaker is not. So the crew would take the interphone off, and then they could either put their headsets back on, or they could choose to use the overhead speaker.
Okay. That didn't used to be that way. The overhead speaker used to automatically come on back in older models. Is that correct? When you went to them?
To my knowledge, not in the 737.
Not in 737, okay. So the crew obviously had difficulty talking to each other right after the decompression. Despite the difficult communications between the captain and the first officer in the cockpit, the captain indicated that he and the first officer had briefed before takeoff that should an emergency arise, that necessitated the return to Portland, they would return to the runway 28 left. That came out of the interviews, I believe. Is that correct?
That's correct.
When the MED plug separation occurred, how critical was this information that had already been discussed and decided upon? How was that for the response that they had? Did that help them since they were having problems communicating?
Absolutely. Part of every takeoff or departure briefing, the crew discusses a return plan if an event of an emergency, and knowing that in action, they would have had the 28 left in mind for the return and the appropriate ILS or localizer in this case set up.
Yeah, and it's important that I've seen over the years as a pilot, many crews, many pilots through the pilot filing just kind of gloss over an emergency on the takeoff brief, gloss over certain things like what their actions are going to be depending on what happens and how important that brief can be in a situation like this. All right. When we started looking at the accident aircraft after the event, we noticed what was noticeable about the O2 mask in seats 26 A, B, C to the passenger mask.
Or missing.
They were missing. Do we know why?
I would imagine they were pulled out the hole during the decompression.
Yeah. So was there somebody sitting at 26C?
No.
No. So there was nobody in that row at all that needed an oxygen mask?
No.
Oh, good thing. Do we know what altitude the cabin reached in the whole process? What was the highest cabin altitude?
That had to be computed from FDR data. It wasn't actually recorded, and the computed values were about 100 feet under less than airplane altitude. So the plug departed the airplane at 14,830 feet pressure altitude, and the calculated cabin altitude was about 100 feet under that. And
Okay.
that was kind of consistent throughout the data. There was a 100-foot discrepancy while on the ground before the accident and after, so that may be a delta. The point being is that the cabin altitude and the airplane altitude were very close, if not identical.
Yeah, that makes sense with a plug missing. The plane's not designed to have that big of a hole, is that correct? All right, I see my time's up, thank you.
Thank you, Member Chapman.
Thank you, Chair. There were 3 lap children on the accident flight. How close were those lap children and their caregivers to row 26 where the door plug blew out? And if it's helpful, I cheated, I looked. They were 5 or more rows away, all of them were.
You beat me to it.
So this next question is really my main point. So thankfully, none of the lap children sustained physical injuries following the rapid depressurization event. But if any of those lap children had been seated closer to the hole in the fuselage, or if the event had happened at a higher altitude, would the potential for serious injury have been greater?
Yes.
Yeah, absolutely. NTSB, I believe, has investigated accidents where lap children were not securely held during an event or were injured more severely than they might have been if they were appropriately restrained in their own seat. Would you like to talk about some of those investigations?
Sure. There were 2 that we cited in our turbulence study that we did a few years ago, whereas their caregiver was holding their child in their lap. They hit severe turbulence, and the lap children were injured. One in which ended up landing a few rows behind its mother in an empty row.
Yeah, my concerns about this issue long predate my time at NTSB. I've long believed that parents of lap children do not fully realize the serious risk to which they're exposing their young children. The experts agree that the safest place for an infant is secured in their own seat. The draft report quotes the American Academy of Pediatrics, which says, if there is turbulence or worse, you may not be able to protect your baby in your arms. And the FAA actually agrees. On FAA's own webpage, titled Flying with Children, it says, securing your baby in an approved child restraint system is, quote, the smart and right thing to do. Yet, the FAA has consistently declined to require usage of restraint systems for children under 2, accepting a lower level of safety than the standard for adult passengers who are required to wear seatbelts. In 1990, over 3 decades ago, NTSB first recommended that FAA require child restraint systems. Our recommendation at that time followed the United Airlines Flight 232 accident in Sioux City, Iowa in 1989. There were 4 lap children on that flight. 3 sustained injuries but survived. 1 tragically was killed. Can I please ask that you talk about the history of our recommendations in this area? And I don't need specific chapter and verse, but if you could just give a little bit of an overview of where NTSB has been on this issue over the decades.
Yeah, the NTSB has made multiple recommendations on having to do with child restraint systems, and the FAA has done some work with regard to standards for seats, but as you pointed out, they have not required them on airplanes. So.
Yeah, FAA has consistently fallen back on voluntary usage of child restraint systems, despite what I think is a very obvious risk to young children. I've never understood FAA's position on this, but they're consistent on it at least. When did we finally close the most recent version of our often reiterated recommendation calling on FAA to require child restraint systems? Do you recall?
I do not know offhand, but I can definitely let you know.
If you could check that. I want to say it was somewhere in the range of 2013. And we've had to, and we'll talk about this a little bit later, we've had to resort to other approaches on this because we just have not been able to persuade FAA that this is an area where they should take action. Chair, I have additional questions in this area, but I will hold those for later. Thanks.
Thank you. Member Inman.
And so I think part of this is also going to be operations, and I'm actually going to go to the oxygen as well in a little bit. But after the accident, Boeing conducted a comprehensive review of its supply chain and production system, for which they added conformance inspections to, I think it was 9 critical build points. How were they identified, and what happens if a product fails one of those inspections?
Sir, we don't have the answer to that question right now.
Okay, fair enough. So I had a similar question during the investigative hearing, and it's astonishing to me that we brought this up, and I think it's important because it's a big discrepancy. On the depressurization certification, the calculated hole size for a 737-9 is 820 square inches. Does that seem accurate?
That is correct.
However, this plane, the fuselage created by that MED was 1,682 square inches, double the amount?
Yes, about double.
So if we know an inherent risk is there for a double that size, why is the FAA not updating that standard?
The standard is at a different pressure. So the certification standard is a hole size of 820 square inches with a differential pressure of 8.35 psi. Boeing does add some conservatism to their analysis and uses a cabin altitude at sea level, so you have more mass of air that has to escape that hole. In our event, we had double the hole size, but our differential pressure was only 5.73 psi.
Why would it be different than what it was tested at?
The certification hole size is testing to make sure that you don't endanger the airplane or break some part of the airplane that would make a much worse accident.
So I guess in your opinion, do you think the current standard is accurate at 862 square inches?
Yes, for what the FAA is certifying, the structure of the airplane, it is correct.
No, I guess I'm curious, is the FAA need to look at that standard a little bit further?
In what regard, sir?
The fact that it was double the size that actually came out. I know standard pressure differential is probably the big difference there.
Yeah, and we didn't break anything. We didn't have any adverse effects to the airplane.
The door plug fell out.
Right.
Is that not an adverse impact to the aircraft?
It didn't cause loss of the airplane. It's not a catastrophic effect.
I would beg to differ with the people who were on that plane, but I understand where you're coming from. Sorry. So we're seeing a lot of, especially, and I'll go back to like after MCAS, and we actually just put out an urgent recommendation on LEAP engines regarding smoke in the cockpit. I know we weren't in the scope of some of that, but we know that they were designed and engineered to open these cockpit doors in the event of a depressurization event. All these were things that were not briefed to the pilots beforehand, correct?
That is correct.
Are we seeing a systemic issue where there's changes in models and makes of airplanes that are not being briefed to the people who are going to be flying them, which puts it at greater risk?
I don't have the answer to that question. Again, back to the Dash 9, Boeing said it was an oversight in the FCOM coming from the NG, but is in regards to other airframes, I don't have the answer to that.
Was it an oversight in regard to the LEAP engines, not letting them know that the cockpit would fill with smoke?
That is my colleague's case.
Okay.
I don't have information on that.
I just think notionally we can put together a number of different things where it may have been an oversight or potentially intentional not to tell pilots that are flying it. So I hope there's a renewed interest in being fully transparent with the people that are operating the aircraft on what changes may be between versions. I'll go on to the next one.
Thank you. Again, I want to commend the cabin crew for Flight 1282 for their professionalism and courage during what was certainly a terrible event. Chaotic is what the first officer said. Explosive is what the captain said in their interviews. In an emergency such as this one, the crew needed to fall back on their training and let the safety procedures they trained for take over, which is exactly what they did to a T. Every second of reaction time certainly mattered, and yet through no fault of their own, there was undeniably chaos. So what we look at now is how carriers like Alaska Airlines can create that redundancy in that system so that in times of chaos, there are first and second lines of defense that will save lives. In this case, I want to talk about the oxygen masks and the portable oxygen units. As soon as the depressurization in the cabin occurred, all 4 flight attendants followed procedure and immediately put on their overhead oxygen masks. They then began to move through the cabin. Some had portable oxygen bottles at some point to check on passengers and the unaccompanied minors on board. It was here that they encountered problems with the oxygen units. What method did each flight attendant use for an oxygen source as they moved throughout the cabin?
The supplemental oxygen, the portable oxygen bottles, as you mentioned, and then there was an alternative mask-to-mask method that one of the flight attendants used to move through the cabin.
Yeah, and how did Flight Attendant C describe the experience of using the mask-to-mask procedure?
I believe her words were utterly ridiculous and challenging. She was moving aft forward using the spare mask at the seat bank, and as she approached the seat bank to get the masks from the passengers, they didn't understand what it was that she needed. She reached over to try to get those spare masks. They were entangled with other masks, and at some point, she also had challenges reaching over to grab them because they were on the outboard side of the airplane.
Yeah. So not everyone, and just turning to the portable oxygen bottles, not everyone is familiar with them, and I know you brought them up earlier, but can you bring up Mr. Zhu, slide 21? And I'd like to read 2 excerpts from the interview transcripts with flight attendants B and D. B said, "For me to get to a mobility portable oxygen bottle was several steps because those are stored in an overhead bin on the aircraft left on the exact opposite side of the lavatories from my jump seat. So I did not have an oxygen mask for maybe 15 or 20 seconds to pull the portable oxygen bottle out of the bin and come back. And while I was in the back trying to take apart the mask that's attached to the portable oxygen bottle, I remember Flight Attendant C saying, put on that other mask for now or whatever, because I was trying to get to the bottle together. What she had the presence of mind to say was grab that other mask that's hanging there and put that on while you're doing that. So I did that and then fumbled around with the portable oxygen bottle and the mask, got that on. I wear glasses, so the elastic strap was getting caught in my glasses and my glasses were all up on the top of my head. Flight Attendant D said it took so much time. This is the number one thing that frustrated me the most. So much time to open that portable oxygen bottle. The plastic wrapper was so hard. Can you talk about what that was experienced there in more detail?
Yes, so the portable oxygen bottle that they're talking about using is a oxygen bottle that's in a plastic container that's been airtight. So it was hard for them to open it. They had to use identification badge, pen to actually rip it open. By the time they got it open, they weren't able to open the mask because it was so sticky and stuck together.
Okay, I'll come back to that. I've got more questions. I'm sure others do as well. So, Member Graham.
I'm going to go back to the crew mask real quick. Did Boeing provide the operator with the information about the crew mask, how the mic worked?
Yes.
Okay. Did the operator do any training on it?
Yes, they did.
Okay, I think I read there was, a slide and some recurrent training, but did they do any in the cockpit in a simulator?
No, the investigation did not yield that.
Did not yield that. So there was an opportunity missed there. And I think this is important for all operators out there. With your safety management system, your change management process is very important here. When you introduce a new model to your fleet or a new derivative, it's important you look at the risk of all the differences out there and make sure you cover it. Now, in case of Alaska, we see that they have covered that since then. They just didn't know. There was some information there, but there wasn't a good operational knowledge of it, I'd say. So that's important. Thank you. I'd like to talk about the oxygen generator systems. What did we find as a result of this accident with the oxygen generator systems for the passengers?
So we found that the oxygen generators did move all but I think 2 rows, slightly aft a little bit, but we did find that all of the oxygen generators retainer pins did pull and the retainer strips did turn color, so all of the oxygen masks did.
They all worked correctly?
Yes, they did.
Okay. What is the hazard of those moving on the pads, the oxygen generators? What could happen if they move enough?
I think the risk is that they may activate by stretching the activation mechanism during that motion and then not be available in a real emergency.
Okay, so we found that out, that some had slid on the pads, correct? What has Boeing done since then about that?
I know that they've made some change to the pads and they've updated their manuals, and they've made changes on all the other aircraft to include the pads.
The new pads are to keep them from moving, correct?
Yes.
So, I mean, I'm glad everything worked okay, and I'm glad we found something out before we needed them. Very good. Did Alaska Airlines flight attendant manual detail what to do if unaccompanied minors were on board during a rapid depressurization event?
No.
Didn't cover anything at all?
No.
Okay. How many unaccompanied minors were on board?
3, 4.
Was it 4? Okay. All right. That's all I have in this section. Thank you, Chair.
Thank you. Member Chapman.
Thank you, Chair. I just want to pick up a little bit on Member Graham's questions about the flight crew and the oxygen masks. At what point did the flight crew decide to remove the oxygen masks and attempt to reestablish communication with their headsets? Do we know?
Yes, in interviews, they stated at about 10,000 feet is when they took the oxygen masks off. And again, after not being able to communicate, they put them back on.
So they would have attempted to go without at the point where essentially it was safe to operate without supplemental oxygen, correct?
That's correct.
Okay. And again, they were unable to reestablish communication because this aircraft had a different system on it from what they were accustomed to, from the 737NG.
That is correct.
Okay. And when the 737 MAX airplanes were first delivered to Alaska Airlines, did Alaska Airlines pilots, did they go through training? They did. I believe you indicated that already. They did go through a differences training. Was that difference, first of all, that differences training was relatively brief, I believe, right? I mean, it was at most a couple of hours.
That's correct. The simulator training was 2 hours.
And was that differences training, is that a reoccurring training or is that a one-time, if you know?
This familiarization flight was in the initial training for the MAX.
Okay.
After that, they could do training on either the NG sim or the MAX sim.
Okay, all right. So something like the difference between the oxygen masks, that's not something that they would have encountered again unless they were doing simulator training in the MAX simulator. Is that right?
That is correct.
Okay. Did we find in the investigation, did we find that Alaska's instructors were also unaware of the differences in procedures on the MAX model and the NG models for donning and removing oxygen masks?
Yes, during the simulator evaluation that we conducted, the 3 instructors that ran the simulator for us, they also were not familiar with having to press the test
Yeah.
to reset switch.
So there's a good discussion of this in the draft report, talking about our long history of recommendations to FAA addressing quick and effective oxygen mask use, including flight crew initial and recurrent training, hands-on, and aircraft-specific training on oxygen mask use. But FAA has, in the past, declined to accept our recommendations in full. They've emphasized instead the importance of training, but they've refused to require some of the things that we've recommended. I know we have a new recommendation that we'll consider today that asks FAA to notify operators of circumstances of this accident and encourage hands-on aircraft-specific training and participation in realistic emergency scenarios training. And I think that's very important, and I think we see from the circumstances of this accident just exactly why that's important. Thanks very much, Chair. I have no more questions.
Thank you. Member Inman.
So I'll go back to what Member Chapman was talking about, and I always find it interesting, and I think it's helpful that if you don't know, the party submissions that we get are valuable, at least for me, and so I appreciate the time and the efforts it's put into. This is actually from the Flight Attendants Association, and they've got a picture in there. They're demonstrating how flight attendants are trained to be able to use masks. And it looks like a large collection. Where that's interesting, though, is you get onto the next page, and they actually have flight attendants that are actually illustrating what it's like on a real-life aircraft, the cup-to-cup, if you will, where it's so hard for them to be able to reach across to the outboard that some of them don't even have long enough arms to be able to get that, which is why they have to mimic for passengers to be able to do that. And so I bring that up. Is there a discrepancy between training and what real life would be in regard to using these masks?
Yeah, maybe a little bit. Yes, I think the masks on this particular aircraft are more outboard than the other 737s that they have. But yes, I think there is a little bit of a discrepancy on how far outboard they have to reach to get those masks.
So are they not receiving adequate training during flight attendant school or during recurrent training? Because from the way the pictures that were illustrated to me is, one is a setup where someone can just reach right there and grab it versus an actual mock-up of an aircraft.
I think it's that. They're taught and they're trained, but the familiarization where they actually get out and do it is what's lacking.
So unlike our pilots who actually have a simulator, they're not actually simulating in a real-world environment.
Yep. And the mask-to-mask method is an alternative way to move about the cabin.
Okay. There was also raised during that report, and I think it's helpful that there were basically, whenever this depressurization event occurs, what does the airplane automatically do? Does it make announcements?
There is an automated PA that's made, yes.
And that's made once, I believe, right after the event occurs?
In English and Spanish, yes.
English and Spanish. So I'm wearing headphones, I'm taking off, think I'm distracted, and suddenly an event happens and this automatic announcement comes off. Do we know how loud it is, or is it repeated a lot of times so people will understand?
Well, in this particular incident, some of the flight attendants didn't hear it. And there was an announcement from the cockpit. I think it's because by the time they got to the emergency checklist or that part of the QRH, they were already at 10,000 feet, if I'm not mistaken. So they had skipped that part of the checklist, so they didn't make a PA to the passengers. So they were solely relying on the automated.
But the automated
announcement.
only happened once and immediately after the depressurization?
Yes. And if the automation fails, the flight attendants do have procedures where they're supposed to yell, stay seated, buckle your seatbelt, get on oxygen, stay on oxygen, no smoking.
They're supposed to yell that while they're actually trying to don their own oxygen mask?
Yes.
Does that seem a little bit problematic?
It could be.
Mr. Brazy, you have anything to add about that?
Sounds like a challenge to me.
Okay. I don't know if it's a challenge we're at least putting out there, but I do think we can do a better job. If we can automate more of the safety portions to where to take the human error out of it, we would be better off. So I appreciate the flight attendants for their submission, at least raising that issue. I never would have imagined it because many of us don't experience it. So where the opportunities, and I don't believe we have any recommendations on that directly in this report, but I think it's worth noting for those who are listening or be looking at it, this is a place we can do better. We talked about the chaotic cockpit, and I know it was referenced a couple of different times. Is there a normal understanding that pilots would go heads down in this type of instance to reinstall their oxygen mask, press a reset button? Is that a normal sequence from maybe a human factors point of view?
You don't have to actually place the oxygen mask back into the stowage box. You can set it aside. But yes, you would expect to close that stowage box door and hit the button to reset communications in the 737-9.
Is that a normal, this is a pilot, I know pilots were looking for a switch, but is that a normal practice to reach down somewhere else, close a door, and perform two different functions in order to get your communications back?
It is. The door is the same in the NG and the MAX. It's just the switch that's on the audio control panel and on the NG versus hitting the test reset switch on the 737-9.
Okay, let's see, I'm out of time.
Thank you. What entity is responsible for the design standards of portable oxygen bottles on board aircraft? We just talked about in my round some difficulties with getting those.
The FAA.
And did these meet current FAA standards?
Yes, they do.
It's obvious those standards need to change. Do we have a recommendation on that?
We do.
And are these masks on, first of all, what did American Airlines do differently afterwards to, Alaska Airlines do differently to address this?
Well, they did update their training and initial and recurrent to provide an exemplar oxygen bottle the flight attendants can see when they're going through training.
But perhaps a different design is needed so that those same difficulties are not experienced in another emergency situation.
Yes.
And are these, is it just these types of difficulties applicable to Alaska Airlines, or could it be other airlines?
It could be other airlines.
Okay, yep, that's my point. All right, Member Graham.
You're talking about the passenger oxygen masks being very far outboard. On the MAX, are they farther outboard than the other 737 variants?
Yes.
Do we know why?
No.
Is it because that bin overhead has to be much bigger now?
Perhaps.
Probably.
Mm-hmm.
I guess that'd be a good question. But, everybody carries their bag now because they don't want to pay for the baggage.
Mm-hmm.
Okay. That's all I have in this section. Thank you.
Right, Member Chapman.
No further questions, Chair.
Member Inman.
So going back again to oxygen masks, is there an alternative to the bag that was described for the flight attendants? I know that was a problematic because it was congealed and it was hard to get around glasses. Is there an alternative for that?
There is. Most airlines in the U.S. do have the plastic yellow Dixie cup mask that you would see for the passenger masks is what they use for the portable oxygen masks.
So does an operator get to decide which type of safety mask they want?
Yes.
And you say that most of the industry has already adopted the Dixie, I guess it's a good way to describe it, Dixie cup, the little yellow cup?
That's correct, yes.
Why would Alaska do this differently? Why would there not be conformity whenever we know that works?
I don't know.
Since I know they've taken multiple different changes, such as training, simulator, things of that sort. Have they made this change since the accident?
They have not, and that's why we made the recommendation, because based on how we know that this performed in this particular accident, I think it needs to be relooked at. Staff believes it needs to be relooked at.
Is this an expensive product? Is it like $50,000 to change a little tubing and a mask to a Dixie cup?
I'm unsure.
Okay. It was reported that 2 of the flight attendants actually believed that they were starting to suffer hypoxia. Can you describe what hypoxia is? And I'm looking to anyone in general.
Well, it's a lack of oxygen for one or more reasons.
What's the effect, though?
Loss of situational awareness, inability to assist other people, oxygen deprivation.
And so 2 of the flight attendants at least acknowledged that they had suffered what they thought were effects of hypoxia from this, correct?
They were lightheaded, yes, they referred to that.
So this event occurred at 15,000 feet. Can you tell me the difference between a depressurization event at 30,000 feet to get down to 10 versus 15,000 to get down to 10? What would the time difference be from 30,000 feet to be able to do a rapid descent back to 10,000?
Well, airplanes are certified that you need to be below 250, flight level 250 within 2 minutes. And you would be flying at VMO or the max operating speed, which is normally, I mean, every airplane's different. It could be 270 knots or maybe 280. In the case here, I think the crew had to think about, was there structural damage, because you might need to fly slower if that was the case. But they would have been able to, after assessing the situation, gathering all available information, making sure that it's not night and they're going to go fly right into a mountain, taking those things into effect, they would be able to get, the airplane is certified to get below 25,000 feet within 2 minutes.
Below 25,000, but to get to where hypoxia is still not occurring is below 10,000.
No, I'm not a doctor, but hypoxia affects different people at different altitudes. The useful time of consciousness is much higher, but that doesn't mean that somebody would get hypoxia sooner or later. Physiologically, we are all different, but at 10,000 feet, you are not required to have oxygen.
So I go back to my original question. If you're going from 30,000 feet down to 10,000, how long would that take? Best case scenario?
A few minutes, 3 minutes.
A few minutes? Okay. And in this instance, it took a few minutes just to get from 15 or 17,000 feet down to 10? That's all time I have right now. Thanks.
Okay, I don't have any more questions in this section. Member Chapman? Sorry, Member Graham. Member Chapman? Nope. Member Inman?
Catch all will be fine.
Okay. I do want to just take a moment and thank Member Chapman for his strong advocacy on the child restraint issue. This really has been something you have championed, and thank you for your work on that. All right, we are going to move to the 4th round, which is on recorders, both their deactivation and 25-hour duration, starting with Member Graham.
Thank you, Chair. Once again, we didn't get any recording off the CVR, did we?
No, we did not.
Recurring theme. I can't remember how many times in the last 5 years I've been here. Way too many. It's just kind of frustrating to see this, that how important the CVR is. I noticed there's a proposed recommendation in the report by staff that asks the FAA to require operators to incorporate guidance into company SOPs or emergency protocols and post-incident and accident checklists detailing actions to preserve the cockpit voice recorder. And having flown myself, I would say crews out there, the most important thing is to get that aircraft, get your passengers and your crew safely on the ground. And the last thing a crew is thinking about at that point is pulling a circuit breaker or doing whatever they have to preserve the CVR. I wouldn't be thinking about that. I'd be thinking about the safety of everybody. So I appreciate this, I support this, but there's a solution to this. I'd say operators, you don't have to wait for a mandate to put a 25-hour CVR on your aircraft. I know a lot of new aircraft are going out there with it already. So just put it on there, bypass this. The other thing is, I know many years ago, we put out a recommendation to the FAA to put together programs where, not unlike flight data recorders with FOQA programs and ASAP, that you monitor what's going on in the CVR. You might learn something about your SOPs or sterilized cockpit from that. But that was closed unacceptable because the FAA didn't want to do anything. But that doesn't stop you, the operator, from doing it at your own program. Remember, the regulations are the bare minimum. I would hope a safe organization that does SMS does more than just what the FAA rules and requirements are. That's all I got in this section. Thank you.
Great, thank you. Member Chapman.
Thank you, Chair. And just picking up on Member Graham's comments, the Alaska Airlines Flight Operations Manual at the time of this accident, as I understand it, required flight crews to pull the CVR circuit breaker as soon as possible after the aircraft was secured. But as Member Graham points out, that it's understandable given the dramatic circumstances. It's understandable why that might be overlooked. Again, the answer here is 25-hour CVRs. The NTSB's pushed for 25-hour CVRs since, I believe, at least 2018. We now have language in the FAA Reauthorization Act of 2024, which requires 25-hour CVRs for Part 121 aircraft. Is that requirement now in effect, or does that require an FAA regulation to implement it? What is the status of that requirement? Do we know?
Yeah, that requirement is now in effect as of May 16, 2025. So all newly manufactured airplanes operating under Part 121, and then certain other operations that have more than 30 passenger seats will have 25-hour CVRs coming out of the factory.
And with regard to Alaska Airlines, how many airplanes in the Alaska Airlines fleet are currently equipped with 25-hour CVRs, and do they plan to retrofit their entire fleet?
Yes, so they indicated to us that they already have 6 airplanes that have 25-hour CVRs. Every new delivery after this will have them, and that they're already working on plans to retrofit their fleet to meet the mandate in the FAA Reauth.
And for them, the task there, they're actually dealing with 2 fleets, because it's the Alaska Airlines fleet and then the Hawaiian Airlines fleet because of the merger, correct?
That's correct, yeah.
Yeah, thank you. Well, this is an example, I think, of what Member Graham is referencing, which is you don't have to wait for the mandate. I mean, you can do these things on a volunteer basis. We have the mandate now, but it's important for carriers to meet the requirements of the mandate and, frankly, beat them if possible. Thanks, Chair.
Thank you. Member Inman.
So I'll go back, I guess, and Member Graham and Chapman both brought it up. Can someone tell me the process of how we preserve this CVR? I know we've talked about this crew operating exceptionally chaotic, but what is the process? And we talked about the SOP. How do you actually preserve the CVR?
So in the event of an incident or an accident, you need to remove power from the CVR for it to stop recording if the airplane is still powered. So the only way to do that would be to remove the CVR circuit breaker.
Is that, I mean, if I go into my house and try to remove a circuit breaker, I'm probably going to either get electrocuted or yelled at by my wife. Is that a hard process to turn around and pull the circuit breaker? Is it laborious? Do you need tools?
It depends on the airplane. Some of them are electronic, but it's not a difficult process, no.
Is it easily accessible?
Yes.
So do we ask why in this instance that it was not done?
I think, as some of the other members alluded to, it was a very chaotic event, and the last thing on the crew's mind after the airplane parked at the gate was to make sure that the circuit breaker was pulled. They had other duties to perform, so that's why we proposed a recommendation in this area to make sure that other people in the operation are aware that they need to get that circuit breaker pulled before it starts overriding itself.
Okay, and in the instance of this circuit breaker issue, It's the crew's responsibility, not the maintenance or the others. In the event of an incident or accident, it's still the cockpit crew?
So yeah, technically in the Alaska Airlines Flight Ops Manual, it is the responsibility of the flight crew if possible, but sometimes maintenance does respond in time to be able to preserve the accident fire recording as well.
Okay. So I know we talked about earlier, actually, I'm just going to wait for the catch-all on the rest of mine, Chair.
Okay, great. And Mr. Brazy, on this point, Alaska Airlines did ask their maintenance personnel to pull it. The aircraft stayed powered, and it was a couple hours, and it was overwritten.
Correct.
Yeah. Okay. So, what could the CVR have helped us with had we had a recording?
So in this accident specifically, I think some staff talked about in presentations. So the flight deck environment during the depressurization, during the opening of the flight deck door, the presence or absence of any oral alerts, and also the difficulties in communication between the flight crew, air traffic control, and others.
Great, thank you. Ms. Adler, when did the NTSB first recommend CVRs be capable of recording 25 hours as opposed to the current standard of 2 hours?
It was 2018, Chair.
And in the 7 years since we first called on the FAA to require 25-hour CVRs, how many more NTSB investigations have been hampered by overwritten CVR data?
I'll confirm with my colleagues in RE, but I believe it's at least 20.
At least 20. And is CVR data only important for NTSB investigators, or are they important for others, such as operators, to determine how to improve safety?
Yes, I believe the operators as well.
And I know that this is important for FAA now and the current leadership at DOT. They have assured me that they are focused on moving this rulemaking forward. Is there anything we can do to help them?
I mean, I think, in general, we have an entire team dedicated to implementing all of our recommendations here in the Office of Safety Recommendations and Communications. We'll continue to assist in any way that we possibly can, using our previous experience, this investigation, and then also using, our investigations to help in other ways when legislation is necessary. We help on the Hill.
And can others describe how the FAA's proposed rule compares to the rules and standards already in place in Europe or ICAO?
Sure. So EASA, which is the FAA equivalent in Europe, has had a mandate for 25-hour CVRs on newly manufactured airplanes only since January 2021, and that is also similar.
And how does that compare to FDR data?
So FDR data is a little bit more complex on the carriage requirements, but generally speaking, for large transport category airplanes, they've been required to have 25 hours or more worth of data for quite some time.
Great, thank you. Member Graham. Member Chapman. Member Inman. And none from me. So we will close out round 4, and before we consider the draft findings, we'll also entertain a final round of questions on any other safety issues that we want to talk about regarding this accident and our investigation. Member Graham.
I have no further questions.
Member Chapman.
Chair, while I have no additional questions, I do want to take a moment to highlight the brave actions of the flight crew and the flight attendants on Alaska Airlines Flight 1282. You made reference to this, extensive reference in your opening comments, and I just want to add a few thoughts of my own. I'm terribly impressed by the flight crew's excellent work as a team during the emergency to get the airplane safely on the ground. And I was also moved by the crew's concern for the passengers. During the chaos in the cabin, the flight attendants made sure the passengers were secured in their seats, and they used portable oxygen supplies to move through the cabin to check on the unaccompanied minors who must have been simply terrified. It's a great reminder of the critical role flight attendants play in ensuring safety during an emergency. According to the transcript of our interview with the first officer, after arriving back to the gate, the first officer helped passengers off the plane. She then walked toward the back of the aircraft to check on the flight attendants. She saw a 6-year-old unaccompanied minor and she held his hand and walked him up to the front of the plane to make sure he was with the other unaccompanied minors before they were escorted off the plane. I want to commend the actions of the entire crew of Alaska Airlines Flight 2082. They were simply outstanding. Thank you, Chair.
All right, thank you. Member Inman.
So we know that there were a number of great things that actually happened, but there were a number of deficiencies as well. Was the communication between the flight attendants and the crew necessary? It's written into the regs, their flight operation manuals. It all says that in a depressurization event. I know earlier we discussed they knew that there wasn't a hole in the back or structural integrity, but we haven't been able to confirm that they actually knew that.
That's correct.
So in these cases, I know they took the initiative to do what they needed to, but if they would have followed the exact procedures, we could have had a different outcome? Is that the best way to put it?
I don't think the outcome would have been different. I think that the flight attendants would have felt better knowing exactly what was going on, and the inability to communicate was very distressing for them, but I do not believe that would have a different outcome.
What about the reverse for the pilots knowing what happened actually in the fuselage?
Yes, they too didn't know exactly what was going on. Again, all the captain heard was whole. They obviously knew it was a rapid depressurization, but to what extent, they did not know.
If they would have known that large of a hole, do you think it would have changed their? And this is speculation, so I don't want to put you in that, but and it's easy after the fact. So we actually had some discussions, I think, about the Spirit and its contractors at one point. We now know that Spirit is being acquired or taken back in by Boeing. I guess in this catch-all kind of phrase, is there additional risk that will be inserted now that they're coming into that? Because we know that they have a different set of audits, I guess, from the FAA, different reporting. Will the acquisition of Spirit make this a better manufacturing process or inject more risk?
I can take that one on. I think that, again, with any major change that you make, there has to be a change management process. We've discussed that earlier, and this would be just one such change. Although, they were together, and then there was a divestiture, and now there's that proposition to bring Spirit back on. One of the things that they'll have to look at is how they will incorporate and mesh together Spirit's existing practices and what Boeing has in place. Can't speak for the future. I just know that it can't be something that is disregarded. The potential for risk being introduced cannot be disregarded, and it has to be assessed. What I can say is, though, as I mentioned earlier, along with the new rule, suppliers were not part of that new rule. And so if this major supplier comes back under Boeing, then they will be under the Boeing certificate and will be subject to Boeing's now regulatory SMS.
Where previously, by being a supplier, they were not subject to it, but
they were not, no.
Okay. I'll go back real quick. I know one of our recommendations is for an independent third-party panel to evaluate Boeing culture. Is that correct?
Yes.
So I'm going to reference again the Inspector General report that was done, and it appears that the FAA actually mandated that with an expert panel that looked, this is part of the Safety Accountability Act of 2020. It's talking about they had 15 findings, 31 recommendations related to Boeing's safety culture and its SMS, and the FAA's ability to oversee Boeing's SMS. Did we look at those in regard to what those recommendations and findings were before our recommendation of basically redoing this expert panel?
So that's the Section 103 colloquial, that's what we've been calling that report. And we did look at, and we found that a lot of what they prescribed in that report mirrored what we also saw in our own investigation.
So even though this was done in 2020, roughly, I don't know when the actual report was done, but is it a recurring issue? Are we going to have to every 5 years go back and say there needs to be an independent panel and an independent review of an SMS system?
I think that there should be constant review, yes. At what interim, I think remains to be seen. I do caution against, I guess, over-surveying and over-assessing, specifically when it comes to, like, for instance, instituting a survey and taking the pulse of the people, only because if there's not demonstrative effects after the fact, if there's no proof that that information is being taken and used for change, people will be less and less likely to be candid when they go to answer the questions of a survey. Because it can always be that perception that, well, I just did this 3 years ago and I haven't seen any change, so why am I doing it again? So there's a couple more things that have to be in place there. And again, it's about holistic change. Taking the assessment of the safety culture is one part of it. A survey, for instance, is a significant data and fact-finding tool, but there are other tools as well, such as small group sessions, large group sessions. These are some of the things that we have seen Boeing do after the fact to gain more and more information, and those environments also lend themselves to different individuals will respond differently to different tools.
Okay, great. We are now ready to move on to the findings, probable cause, and safety recommendations. Ms. Schultz, will you please read the proposed findings?
Certainly, Chair. As a result of this investigation, staff proposes 34 findings. Number 1, the flight and cabin crew members were certificated and qualified in accordance with applicable federal regulations and Alaska Airlines requirements. Number 2, there was no evidence that Alaska Airlines performed any maintenance, inspection, or retrofit work on the airplane since delivery that would involve opening the left mid-exit door plug. Number 3, the left mid-exit door plug displaced incrementally upward during previous flights. Then, during the accident flight, it displaced upward to the point of stop pin to stop pad instability, then upward, outboard, and aft as it separated from the fuselage. Number 4, the evidence of the upward displacement of the left mid-exit door plug before the accident flight would not have been readily detectable by a flight crew member performing a routine pre-flight walk-around inspection. Number 5, the airplane's cabin pressurization system operated as designed both before and after the left mid-exit door plug, MED plug, separated, and there was no evidence that the previous pressurization system auto-fail light illumination events were associated with the left MED plug's upward displacement during previous flights. Number 6, the flight crew's immediate actions to don their oxygen masks after the rapid depressurization and use the cabin altitude or rapid depressurization checklist were consistent with company procedures. Their decision to descend the airplane and return to the departure airport was timely and appropriate, and they demonstrated effective high workload management and task allocation appropriate for a 2-person crew to safely handle the emergency. Number 7, the teamwork and complementary duties of the flight crew, which occurred during the emergency, reinforced the necessity for a minimum crew of 2 pilots, as specified in the airplane type certificate, as well as Title 14 Code of Federal Regulations, Part 121 Operating Rules. Number 8, although the flight crew did not perform the procedures to switch communications back to their headsets after removing their oxygen masks, this had no adverse effect on their subsequent safe landing of the airplane. Number 9, Flight Attendant A's difficulty communicating with the flight crew and challenges communicating with the other cabin crew members did not impede the cabin crew's ability to execute cabin procedures and effectively ensure the safety of the passengers, including unaccompanied minors, after the rapid depressurization and during the descent and return to the airport. Number 10, all flight attendants and passengers were able to use the overhead oxygen masks to obtain oxygen after the rapid depressurization, and the portable oxygen bottles provided oxygen to the 2 flight attendants who used them to move through the cabin. Number 11, the absence of bolt contact damage or deformation around the holes associated with the vertical movement arrestor bolts and upper guide track bolts indicates that the 4 bolts that should have been installed to prevent the left mid-exit door plug's upward movement were missing before the plug moved upward off the stop pads. Number 12, the left mid-exit door plug's vertical movement arrestor bolts, upper guide track bolts, and associated hardware were installed before the fuselage was delivered to Boeing, but subsequently removed during the manufacturing process when the plug was opened to facilitate additional work. Number 13, neither the door team manager nor any of the door team personnel on duty when the left mid-exit door MED plug was opened had any experience with opening an MED plug, and none said that they had any knowledge of who opened it. Number 14, whoever opened the left mid-exit door plug did not generate a removal record, which increased the risk that the closure would not be performed properly due to the absence of the documented steps for the bolts and hardware to be reinstalled and for a quality assurance inspection to verify that the installation was restored to accepted condition. Number 15, Boeing Commercial Airplanes Business Process Instruction, perform part or assembly removal, lacked clarity, conciseness, and ease of use to be an effective tool for manufacturing personnel to consistently and correctly determine when and how to generate a removal record. Number 16, Boeing Commercial Airplanes on-the-job training was unstructured, undocumented, and focused primarily on routine build tasks, which decreased the likelihood that door team personnel with limited exposure to non-routine tasks would be able to correctly perform the process for opening a mid-exit door plug, including generating the required removal record. Number 17, only door team personnel were allowed to perform work on doors and mid-exit door MED plugs, but none were on duty at the time the left MED plug was closed. Number 18, due to the absence of a removal record indicating that the left mid-exit door plug installation had been disturbed, no quality assurance inspection of the plug closure was performed. Number 19, the post-accident design enhancement of the mid-exit door MED plug, if certified by the Federal Aviation Administration and implemented by Boeing Commercial Airplanes, will help ensure the complete closure of an MED plug following opening or removal. Number 20, because Boeing Commercial Airplanes did not conduct a change management assessment to identify and address the risks associated with using a workforce with reduced experience, including hiring many with little or no previous manufacturing experience, it missed an opportunity to proactively implement mitigations to ensure quality standards were maintained. Number 21, although accepted by the Federal Aviation Administration, Boeing Commercial Airplanes' corrective actions were ineffective to address the persistent deficiencies with Boeing's business process instruction, perform part or assembly removal, which had a documented history of compliance issues for at least 10 years before the accident. 22, although Boeing Commercial Airplanes' short stamp process for deferred or traveled work does not negate the need to generate a required removal record for disturbed installations, had the short stamp process been correctly applied on Boeing installation plan OK to install blankets for the accident airplane, it may have provided an opportunity for personnel to detect the left mid-exit door plug's missing bolts and attachment hardware. Number 23, the Federal Aviation Administration's compliance and enforcement surveillance, audit planning assessments, and record systems were deficient and lacked the functionality necessary to identify repetitive and systemic discrepancies and non-conformance issues with Boeing Commercial Airplanes business process instruction, perform part assembly or removal, including previous instances of undocumented parts removals. Number 24, Boeing Commercial Airplanes Quality Escape Guidance, which focused on components rather than the actions of people performing tasks, did not adequately address controls for human error, leaving a gap in Boeing's ability to identify and build effective mitigation strategies. Number 25, in the 2 years before the accident airplane's production, Boeing Commercial Airplanes Voluntary Safety Management System was an immature program that lacked the formal Federal Aviation Administration oversight and did not proactively identify the risk of the quality escape that occurred. Number 26, having a fully developed safety management system implemented at every level of the quality management and production process will provide Boeing Commercial Airplanes with a systemic approach to proactively identifying and managing the human risks associated with aircraft production. Number 27, due to the mixed perspectives provided by the relatively small sample size of employees interviewed about the accident airplane's left mid-exit door plug and the prolonged work stoppage at Boeing commercial airplanes that precluded the National Transportation Safety Board from conducting a broader safety culture survey, an assessment of Boeing's safety culture, including whether adverse pressure existed on the production line, could not be performed as part of this investigation. Number 28, for future implementation of Boeing commercial airplanes' regulatory safety management system and integration into its quality management system to be successful, accurate and ongoing data about its safety culture is needed. Number 29, the circumstances of this accident and others highlight the need for hands-on, aircraft-specific crew training and procedures for the use of each type of oxygen system in an operator's fleet, including donning masks, communicating with them on, and reestablishing communications after removing masks. Number 30, although the portable oxygen bottles used by the flight attendants met Federal Aviation Administration design standards, the difficulties the flight attendants encountered when using the masks, including the need to improvise a tool to open the packaging, suggest that the standards, the mask design, or both do not adequately consider ease of use and quick donning in an emergency. Number 31, Alaska Airlines procedures at the time of the accident were ineffective in ensuring that the cockpit voice recorder data were preserved from the accident flight, resulting in the loss of critical information for the investigation. Number 32, the circumstances of this accident and others show that cockpit voice recorders, CVRs, with a 25-hour recording capability are necessary because valuable information continues to be overwritten on CVRs that are designed to record only 2 hours of audio data. Number 33, the Federal Aviation Administration's emphasis on increasing voluntary usage of child restraint systems rather than mandating their use, as the National Transportation Safety Board has long recommended, has continued to allow children under the age of 2 to travel on board aircraft at a lower level of safety than that of seatbelt-wearing adult passengers. And number 34, although the caregivers of the 3 lap-held children on board the accident flight did not report any difficulty holding on to their children during the rapid depressurization, the circumstances of this accident and others show that the potential for severe injury or death exists for children less than 2 years old who are not secured in a child restraint system appropriate to their size and weight.
Thank you very much, Ms. Schultz. And I know we have a couple of amendments to the findings. I'm going to recognize Member Chapman first for an amendment to finding 34. Do you have a motion?
I do, Chair. I move that we amend finding 34 as follows. Strike the opening clause up to the point of the comma and substitute this language. Although none of the 3 lap-held children on board the airplane sustained injury, comma. And the proposed final wording of this finding would be as follows. Although none of the 3 lap-held children on board the airplane sustained injury, the circumstances of this accident and others show that the potential for severe injury or death exists for children less than 2 years old or who are not secured in a child restraint system appropriate to their size and weight.
Thank you. Is there a second?
Second.
Great. Starting with Member Chapman for discussion.
Chair, I'm offering this because I believe it keeps a cleaner focus on this second part of the finding, which is that the circumstances of the accident demonstrate the potential for severe injury or death. I think the opening clause that I've offered makes this a cleaner finding.
Thank you. Others like to make any comments? Okay. Staff, do you have a position?
Staff concurs.
All right. Council, go ahead and call for a vote and tally the vote.
Okay, Chair. Board, if in favor of the amendment to finding 34, say aye. If opposed, say nay. Member Graham.
Aye.
Member Chapman.
Aye.
Member Inman.
Aye.
And Chairman Homendey.
Aye.
Chair, the vote tally is 4 in favor of adopting the amendment.
Great, thank you, and thank you to Member Chapman for his work on that. And we have another amendment. I'm going to recognize Member Inman for a motion.
Yeah, so this is not actually an amendment, but it is a additional finding to the current ones. And the new finding would read, and I believe this was circulated earlier, while hands-on oxygen mask simulator training was provided to the crew before the incident, it lacked realistic scenario-based exercises and therefore failed to adequately prepare them for potential real-world events.
Great, and is there a second?
Second.
Board discussion, starting with Member Inman.
This was originally paired with a recommendation as well, but I think the crazy thing about this is we researched it. We made similar recommendations and findings over 15 years ago in regard to real-life scenario training, and the FAA closed this as unacceptable. I hope they'll take a chance to look back at not only this finding, but the recommendation and recommendation 8 that talks about these things that need to be done in order to make sure everyone's operating safe and the crews and flight attendants and passengers can all get home. I think we don't often learn from the mistakes of the past, so I'm hopeful that between this and the recommendation 8, we'll see some success with the FAA this time around.
Further discussion by other members? Go ahead, Member.
I think it's important. It's not just about safety, but it's preparing the crew for that unexpected event. That's what we're doing in the training. That's what most of your training is out there. When you go back to recurrent, is preparing for that unexpected event. So I'm supportive of this, but I'd like to hear what staff thinks.
Agreed. Staff position?
Staff concurs.
Thank you very much. We'll go straight to a vote. Mr. McMurray.
All right, Board, this is the vote in favor of adopting the new finding. Member Graham?
Aye.
Member Chapman?
Aye.
Member Inman?
Aye.
And Chair Homendey.
Aye.
Chair, the vote tally is 4 in favor of adopting the new finding.
Thank you very much, and thank you to Member Inman for offering that additional finding. And Ms. Schultz, if you'll go ahead and read the draft probable cause.
Certainly, Chairman.
Did you want to adopt the findings as amended?
Sorry, we're going to have to adopt the proposed findings as amended. Yes, it's actually right in front of me. Motion to adopt the findings as amended. Member Inman, I'll second. Go ahead and tally the vote.
All right, Board. The vote on adopting the findings as amended. Member Graham?
Aye.
Member Chapman?
Aye.
Member Inman?
Aye.
And Chair Homendey.
Aye.
4 in favor, Chair.
Take it away, Ms. Schultz.
Will do. Staff proposes the following probable cause. The National Transportation Safety Board determines that the probable cause of this accident was the in-flight separation of the left mid-exit door MED plug due to Boeing commercial airplanes' failure to provide adequate training, guidance, and oversight necessary to ensure that manufacturing personnel could consistently and correctly comply with its parts removal process, which was intended to document and ensure that the securing bolts and hardware that were removed from the left MED plug to facilitate rework during the manufacturing process were reinstalled. Contributing to the accident was the Federal Aviation Administration's ineffective compliance, enforcement, surveillance, and audit planning activities, which failed to adequately identify and ensure that Boeing addressed the repetitive and systemic nonconformance issues associated with its parts removal process.
Thank you very much, Ms. Schultz. Is there any amendments to the probable cause? Hearing none, is there a motion to adopt the probable cause as presented?
So moved.
Second.
Okay, great. Any further discussion? All right, council will tally the vote.
All right, Board, this is a vote on the probable cause as presented. Member Graham?
Aye.
Member Chapman?
Aye.
Member Inman?
Aye.
And Chair Homendey.
Aye.
4 in favor, Chair.
Great. And Ms. Schultz, if you can go ahead and read the proposed safety recommendations.
As a result of this investigation, staff proposes the following 19 new safety recommendations. 10 to the Federal Aviation Administration. Number 1, Once you complete the certification of Boeing Commercial Airplanes Design Enhancement for ensuring the complete closure of Boeing 737 mid-exit door MED plugs following opening or removal, issue an airworthiness directive to require that all in-service MED plug-equipped airplanes be retrofitted with the design enhancement. Number 2, revise your compliance enforcement surveillance system to ensure that it provides the necessary functionality for Federal Aviation Administration managers and inspectors overseeing production approval holders to effectively identify, record, track, and resolve recurring and systemic discrepancies and nonconformance issues, including those related to specific manufacturing processes. Number 3, revise your audit planning activities to ensure that they provide the necessary functionality for Federal Aviation Administration managers and inspectors overseeing production approval holders to effectively identify, record, track, and resolve recurring and systemic discrepancies and nonconformance issues, including those related to specific manufacturing processes. Number 4, revise your record systems to ensure that they provide the necessary records for Federal Aviation Administration managers and inspectors overseeing production approval holders to effectively identify, record, track, and resolve recurring and systemic discrepancies and nonconformance issues, including those related to specific manufacturing processes. Number 5, once the actions in Safety Recommendation 2 through 4 are completed, develop guidance for Federal Aviation Administration managers and inspectors who provide oversight of production approval holders on how to identify, record, track, and effectively address repetitive and systemic discrepancies and nonconformance issues, to include strategies for assessing the effectiveness of corrective actions taken by the production approval holder during the previous year. During the previous year when developing next year's certificate management plan. Number 6, once the actions in Safety Recommendation 5 are completed, provide Federal Aviation Administration managers and inspectors who provide oversight of production approval holders with recurrent training on how to identify, record, track, and effectively address repetitive and systemic discrepancies and nonconformance issues, to include strategies for assessing the effectiveness of corrective actions taken by the production approval holder during the previous year when developing next year's certificate management plan. Number 7, retain historical compliance enforcement surveillance and audit records older than 5 years and provide Federal Aviation Administration managers and inspectors access to these records to enhance their oversight planning for production approval holders. Number 8, notify operators of the circumstances of the accident involving Alaska Airlines Flight 1282 and encourage them to review their flight crew training programs and ensure that they include hands-on, aircraft-specific training and procedures for each type of oxygen system in the operator's fleet, to include establishing and maintaining communications when the oxygen masks are donned and removed while participating in realistic emergency procedures training. Number 9, review and revise as necessary the design standards that apply to portable oxygen bottle design to ensure that they adequately address ease of use and quick donning in an emergency situation, including considerations for the effort needed to remove the mask from its packaging. Number 10, require operators of airplanes equipped with a cockpit voice recorder, CVR, to incorporate guidance into company standard operating procedures, emergency protocols, and post-incident and post-accident checklists applicable to both flight crew and non-flight crew personnel, detailing actions to preserve CVR recordings as soon as practical after completion of a flight with a reportable event. 9 recommendations to the Boeing Company. Number 11, continue the certification process for the design enhancement for mid-exit door plugs to ensure that, once the design enhancement is certified, all applicable newly manufactured airplanes are equipped with the enhancement. Number 12, once the design enhancement for mid-exit door MED plugs is certified, issue a service bulletin to address retrofitting in-service MED plug-equipped airplanes with the design enhancement. Number 13, apply your updated safety risk management process to current and future revisions to business process instruction perform part or assembly removal to ensure that it provides clear and concise guidance for determining when a removal record is needed. Number 14, develop recurrent training on business process instruction, perform part or assembly removal for Boeing commercial airplanes manufacturing personnel that emphasizes the importance of removal records for product safety, prepares personnel to consistently and correctly determine when a removal record is needed, and ensures that a removal record is generated when required. Number 15, develop a structured on-the-job training program that identifies and defines tasks necessary for manufacturing personnel to be considered fully qualified in their job series, and includes a grading system for trainers and trainees to track progress and determine competence. Number 16, document and archive the results of training provided and received as part of the program recommended in Safety Recommendation 15 to support future data analysis. Number 17, revise your safety risk management process to ensure that it, 1, identifies the root causes of manufacturing process compliance issues, like the persistent deficiencies with business process instruction, perform part or assembly removal, and other production process inconsistencies identified in this investigation, and 2, evaluates the effectiveness of corrective actions. Number 18, as you integrate your quality management system and safety management system, develop a process that can identify escapes that result from human error, assesses them using a system specifically designed to identify factors that contribute to such errors, and implement effective mitigation strategies. Number 19, reconvene a third-party independent panel to do a safety culture review to inform the continued development of Boeing commercial airplanes' regulatory safety management system and integration into its quality management system. Staff also proposes reiterating the following safety recommendations. 4 to the Federal Aviation Administration. A-18-30. Require all newly manufactured airplanes that must have a cockpit voice recorder CVR be fitted with a CVR capable of recording the last 25 hours of audio. A-24-9. Require a retrofit of all cockpit voice recorders, CVR, on all airplanes required to carry both a CVR and a flight data recorder with a CVR capable of recording the last 25 hours of audio. A-21-40. Conduct a study to determine the factors that affect caregivers' decisions about the use of child restraint systems, CRSs, when traveling on a Title 14 Code of Federal Regulations Part 121 air carrier airplane with children under the age of 2, and to understand the challenges associated with using CRSs. Publish the study findings. A-21-41. After the action and safety recommendation A-21-40 is completed, use the study findings to direct the Federal Aviation Administration's efforts to increase child restraint system usage. And 1 recommendation reiterated to the Airlines for America, the National Air Carrier Association, and the Regional Airline Association. A-21-45. Coordinate with your member airlines to develop and implement a program to increase child restraint system, CRS, usage in airplanes. This effort should include collecting data to determine the program's effectiveness at increasing CRS usage.
Ms. Schultz, can you read recommendations 5 and 8 to FAA one more time? And then I have a couple from Boeing, for Boeing.
Okay, sure. You said recommendation 5 and 8? Okay. 5 is, once the actions and safety recommendations 2 through 4 are completed, develop guidance for Federal Aviation Administration managers and inspectors who provide oversight of production approval holders on how to identify, record, track, and effectively address repetitive and systemic discrepancies and non-conformance issues to include strategies for assessing the effectiveness of corrective actions taken by the production approval holder during the previous year when developing next year's certificate management plan. That's 5, Chair. And number 8, notify operators of the circumstances of the accident involving Alaska Airlines Flight 1282 and encourage them to review their flight crew training programs and ensure that they include hands-on, aircraft-specific training and procedures for each type of oxygen system in the operator's fleet, to include establishing and maintaining communications when the oxygen masks are donned and removed, while participating in realistic emergency procedures training scenarios.
Great. And can you read 13 and 14 to Boeing?
Yes. Number 13, apply your updated safety risk management process to current and future revisions to business process instruction, perform part or assembly removal, to ensure that it provides clear and concise guidance for determining when a removal record is needed. And you said number 14 as well, Chair. Number 14, develop recurrent training on business process instruction, perform part or assembly removal for Boeing commercial airplanes manufacturing personnel that emphasizes the importance of removal records for product safety, prepares personnel to consistently and correctly determine when a removal record is needed, and ensures that a removal record is generated when required.
Okay, so there was just a little bit of confusion up here because the memo to board members on June 20th has the changes to recommendation 13 and 14, but we weren't provided the page changes, so we're all reading the older version of 13 and 14. So I wanted to make sure that we were all on the literal same page as you all.
Okay.
Thank you very much
Absolutely.
for that. Appreciate it. I know there were a lot of recommendations there. So I have an amendment to recommendation 19, and that recommendation I will offer a motion. It would now. It currently reads, if you can pull up 19. Yes. So it currently reads to the Boeing company. My amendment would change that to FAA, and instead of reconvene, it would say convene an independent third-party panel to conduct a comprehensive review of Boeing commercial airplanes safety culture, period. The findings should be used to enhance the ongoing development of Boeing commercial airplanes regulatory safety management system, SMS, and the integration of its SMS into its broader quality management system, QMS. Is there a second?
Second.
Thank you. And just, first of all, let me thank Member Graham. We worked together on this, and I really appreciate his input. Thank you for that. And just to restate some of what was stated during the board meeting, I think staff probably meant to send this to FAA because Boeing had not convened a third-party panel in the first place, so reconvening a panel would really be that ODA panel, a reference to that ODA panel from before in 2020, and I think the intent here is to have FAA, and Dr. Woods talked about having an independent entity would provide something where there was no bias or less bias, and so in this case, not directing that it should be on ODA, but convening another panel so that they could assess Boeing's safety management system and the development of that and safety culture since this accident, since that previous one was well before it. So that is the intent, and welcome comments from my colleagues.
I support the change, Chair.
Okay. Thank you. Staff position? Or, I mean, do you have? Okay.
Staff concurs.
Okay, thank you very much. And council, can you tally the vote?
Yes, Board, this is a vote in favor of the amendment to recommendation 19. Member Graham.
Aye.
Member Chapman.
Aye.
Member Inman,
Aye.
and Chair Homendey.
Aye.
4 in favor, Chair.
All right, so I'll ask for a motion to adopt the proposed recommendations as amended.
So moved. Second?
Great. And council, can you tally the vote?
Yes, Board, this vote is in favor of adopting the recommendations as amended. Member Graham.
Aye.
Member Chapman.
Aye.
Member Inman.
Aye.
And Chair Homedy.
Aye.
4 in favor, Chair.
All right, so now we're moving to the final report. Are there any amendments to the final report in its entirety? Hearing none, is there a motion to adopt the final report as amended?
So moved.
Second.
Great, and further discussion? All right, council, please tally the vote on the final report as amended.
Or as presented,
Actually, we're
Oh,
amending the
okay.
entire report.
as amended. Thank you, Chair. All right, Board, if in favor of the report as amended, Member Graham.
Aye.
Member Chapman.
Aye.
Member Inman.
Aye.
And Chair Homedy.
Aye.
4 in favor, Chair.
All right, is there any member wish to reserve the right to file a concurring or dissenting statement?
I do, Chair.
I do, Chair.
I do as well. You'll be the odd man out.
Oh, I'll do the same.
Oh, right. All of us will reserve the right to file a concurring or dissenting statement. Brian's not happy right now. I just made it difficult for him. To be appended to the report. And with that, I did commit at a previous board meeting to allow board members to make some closing remarks. So we'll start with Member Graham.
Thank you, Chair. I just want to thank the team again for the great work they've done in a very difficult investigation when you're looking at processes and procedures of how somebody built an aircraft. I know it's very difficult, but I thank you for your professionalism and your hard work over the last, I guess, year and a half now. Great job. And I also want to thank Boeing, Spirit, and Alaska Airlines for opening up their operation to me, showing me what they do, how they do it, and what they've changed since this accident. So I appreciate your hospitality and your openness and in our discussions. That's all I have. Thank you.
Great, thank you. Member Chapman.
Thank you, Chair. I, too, want to thank our team for the outstanding work. I know this was a complicated investigation. It was very well done, the report. I'm very proud of the report. I think it's a great product. I am, Chair, going to step up on my soapbox one last time on lap children. That probably won't surprise you. Again, there were 3 small children on board Flight 1282 who were flying unrestrained and without a seat, and they're so-called lap children. Very thankfully, none of those children were seriously harmed, but it doesn't take much to imagine a more devastating outcome. Today, we're reiterating our 2021 recommendation calling on the leading airline industry trade associations to coordinate with their member airlines to develop and implement a program to increase usage of child restraint systems. I was an advocate for our 2021 recommendation, and I support today's action to reiterate that recommendation. Of course, the need for it stems from FAA's minimalist approach to encouraging the use of child restraint systems. FAA has long declined to require child restraint systems for young children. By regulation, in fact, the FAA says it's okay for young children under the age of 2 to travel by air while seated unsecured in an older passenger's lap. For parents lacking further information, FAA's explicit authority allowing lap children to fly unsecured implies the practice is safe. Because, after all, the agency responsible for regulating air safety says it's okay. The existing regulatory structure calls on parents or other caregivers to override FAA's implied safety judgment and substitute their own. Unfortunately, families can only make the safest choice if they know enough to understand the serious risk to which they are exposing their children. And FAA has made little effort to educate the public about the risk to lap children, a risk which FAA acknowledges but has declined to regulate. We need to keep after the folks at the FAA. They have it wrong when it comes to the safety of young children, and we should remind them at every opportunity. Meanwhile, the premise of our 2021 recommendation to the airline trade associations is that we haven't so far been able to count on FAA to do the right thing. We have to look directly to the airlines to help better inform parents and caregivers of the risks associated with young children flying unsecured. I urge the airlines to take our recommendation to heart and help to ensure that this dangerous gap in safety is addressed. Chair, thank you for your indulgence.
Thank you, Member Chapman. Member Inman.
Thank you. I'm actually going to try to take back 1 or 2 minutes. I think in the catch-all round, I wasn't able to ask a question. I've tried to ask at every board meeting. So if you'll indulge me, Managing Director, how many investigations do we currently have open across all modes of the NTSB right now?
Let's see, Member Inman. We have a total of 1,047 investigations open across all modes.
Do you know how many we've completed this past year, or in a reference point?
I don't actually have that number with me, but I can tell you, in addition to the open cases, we've just since January 1st, all modes, we've opened an additional 1,760 cases. So I don't want to hazard to guess. I can get you that number
It's okay,
for the
but
closures.
we've
but
opened 1,760 this year.
since January 1st, yes.
Okay. Tim, can you tell us in aviation alone how many you currently have open?
Well, if you don't mind, I'd like to at least level set a little bit so somebody doesn't lose their false teeth. So we generally do around 1,200 investigations a year. On top of that, it's another 450 that we assist foreign governments. So with that in mind, right now we have about 932 open cases, and I think it's around 200 some foreign cases that we're assisting with. But I am proud to say that for the last several years, we've actually completed more cases than we've taken in. And all that with about 115 AS staff members.
Pretty proud of them, I suspect.
I am.
Yeah. So I guess my point is that I've asked that every board meeting I've been at, how many active, because while this was a tragic event, luckily no one died, but it's been a tough 6 months for aviation safety. And I know everyone has been worn thin. I know the public's concerned. If anything, I guess that we should convey is that we are on the job 24 hours a day, 7 days a week. These are proud individuals that work across the modes. I know we have some of our Alaska staff that are here that are working some significant tragedies up there. And I think all of us can convey we're proud of you, we're proud of the work you do. But it has been a tough 6 months, and it will be another tough 6 months. But for 62 years, all we've done is advocate to make things a little safer. And so for that, I'm very proud of the work you do. And no matter whether your accident gets a board meeting, I know with the investigative hearing, we had 3,000 unique people watching from 42 countries. The DCA press conferences, millions watched, 120 plus countries. Next month, we'll be tackling another issue on aviation safety. All of them are important because you never can tell when it's going to be important to you in that accident. So for that, I'm proud of the work that the NTSB is doing for its members. I know it's been an acknowledgement of a tough 6 months, and it'll be another tough 6 months, but we will get better, and we will continue to advocate and try not to repeat the mistakes of the past. Thank you.
Thank you very much. And I do want to extend my sincere appreciation to members Graham, Chapman, and Inman, and certainly their staff for all their collaboration and work in preparation for this board meeting and throughout the investigation. And I want to also add that I also extend my sincere thanks to you all. There's only a small portion of you here that worked on this investigation. So many others throughout the agency did. And thank you for all your work, and thank you for your expertise. I also want to make sure that, and this is for the Office of Aviation Safety and for Research and Engineering, But also I'll add a lot of work that we don't see at the NTSB was done on this in the Office of General Counsel. And so I really appreciate all your work throughout. It really enabled us to pursue our investigation, and thank you for that. And of course, the Office of Managing Director, appreciate that. We also express our strong appreciation today for helping support this vital meeting. The Office of Chief Information Officer, the Digital Services Division, and the Office of Safety Recommendations and Communications for its diligent work to make sure that our recommendations are taken seriously and to work towards implementation of those recommendations. When acted upon, those recommendations we've issued today will improve safety. I'd also like to thank the following organizations for their collaboration with us on scene and their role as parties to our investigation. The Federal Aviation Administration, Alaska Airlines, the Airline Pilots Association, the Association of Flight Attendants, the Boeing Company, Spirit Aerosystems, and the International Association of Machinists Union. The NTSB works under what we call the party system, meaning we bring together technical experts from those involved in the accident to help us gather and develop the facts around the investigation. Parties are not part of the analysis or development of the findings, probable causes, or safety recommendations, but they are critical to helping us obtain information we need to carry out our safety mission. At the same time, parties get access to what we're finding in real time over the course of our investigation, so they don't have to wait to make safety change. Finally, the NTSB looks forward to working with the following organizations to implement our recommendations: the Federal Aviation Administration, the Boeing Company, Airlines for America, the National Air Carrier Association, and the Regional Airline Association. I do want to add one more bit of thank you, and that's to all the airlines. The airlines themselves reached out to Boeing to assist them in development of their safety management system, and I think that is incredibly helpful as they have significant expertise in developing a comprehensive system themselves and are a incredible resource for Boeing. With that, I'd like once again to offer our sincere thanks to the crew of Flight 1282 for their exemplary professionalism following the accident, and to the passengers and every member of the flying public. Know the NTSB will work diligently to implement our safety recommendations so an accident like this never happens again. Thank you so much, and we stand adjourned.